Hello there, and welcome to Life Beyond Seen, where the quiet places of the world have a way of holding the loudest secrets. There is something about a lake, not an ocean, not a vast and indifferent sea, but a lake, something contained, something you can see across on a clear morning, something with a far shore and fishing boats, and the smell of water warming in the sun. Lakes feel known. They feel like places that have been understood for a long time, and the Sea of Galilee is perhaps one of the most known lakes in the entire world. It has been written about, painted, prayed beside, and sailed across for thousands of years. Pilgrims have come to its shores since before the word pilgrim existed. Fishermen have worked its water in every century anyone can remember. It is, in almost every sense, a familiar place. And yet, beneath that familiar surface, in the murky dark of the southern basin, there sits something that nobody has been able to fully explain, something enormous. Something built by human hands at a time so distant that the hands themselves are long gone. A structure made of basalt stone stacked into a cone shape, roughly 230 metres across at its base, rising about 12 metres from the lake floor. A structure that weighs, by current estimates, somewhere in the region of 60,000 tonnes. To put that in perspective, and we will come back to this in much more detail later, the entire weight of Stonehenge, all of it, every stone, is estimated at around 4,000 tonnes. The structure at the bottom of the Sea of Galilee is 15 times heavier than Stonehenge, and for most of recorded history, nobody formally noticed it was there. Tonight we're going to spend some time with this structure. We are going to look at what it is, how it was found, what researchers think it might be, and what it might mean. There are no certain answers. That is part of what makes it worth sitting with. Some of what we know is solid. Some of it is careful speculation, and some of it is simply unknown, and honestly might remain that way for a long time. But the story itself, the shape of the mystery, is worth telling slowly. Before we go any further, a gentle question for you tonight. Where are you listening from? Are you in a room with the lights low, or maybe lying somewhere comfortable with the sound of this in your ears? Is it late where you are, or early, or somewhere in that strange middle hour when the world outside has gone quiet and something like this feels exactly right to think about? Whatever your answer is, I am glad you're here. If you find yourself enjoying this kind of story, slow, careful, curious, then a like on this video and a subscription to the channel would mean a great deal. It helps other people find this kind of content, and it lets us keep making it. Now, back to the water. The Sea of Galilee sits in the northeast of what is now Israel, in a region that has been continuously inhabited for longer than almost anywhere else on Earth. The lake itself is fed primarily by the Jordan River, which enters from the north, and it drains southward into the lower Jordan as well. It is not a particularly large body of water, about 21 kilometres from north to south, and roughly 13 kilometres across at its widest point. You could sail across it in a few hours in a modest boat. On a calm morning, the far shore is clearly visible. It is, by the standards of lakes, almost intimate. What makes it unusual geographically is where it sits. The Sea of Galilee lies approximately 210 metres below sea level, making it one of the lowest freshwater lakes in the world. It sits within the Jordan Rift Valley, a deep geological scar that runs from the Golan Heights in the north, down through the Dead Sea and all the way south into the Red Sea. The landscape around it is dramatic. Basalt plateaus to the east, the Galilee Hills to the west, volcanic rock almost everywhere you look. The region has a geological history that is restless and layered and very, very old. The lake's shores carry an enormous weight of human history as well. The towns of Tiberias, Capernaum, Magdala, Bethsaida. These names appear in religious texts, in historical records, in the accounts of travellers going back 2,000 years and more. Fishing has been the defining activity of the lake communities for millennia. The same species of fish that are caught today, the Galilean tilapia, sometimes called St. Peter's fish in the local restaurants, have been caught here since long before anyone was writing things down. The lake feeds people, it always has. It is also, importantly, a shallow lake. The northern and central basins are relatively deep, reaching about 43 metres at their deepest points, but the southern basin, where our structure sits, is considerably shallower. In the area of the structure, the water depth ranges from roughly 9 to 16 metres depending on the lake's current level. That is not a great depth. It is the kind of depth that a reasonably experienced diver can reach without enormous difficulty. It is not the crushing darkness of the ocean floor. It is in many ways reachable, and yet what sat down there went unrecorded in any formal scientific sense until the early years of the 21st century. In 2003, a team from the University of Haifa was conducting a sonar survey of the lakebed as part of a broader archaeological mapping effort. The researchers involved, Yitzhak Paz and Danny Nadel among them, were not specifically looking for anything dramatic. Sonar surveys of lake floors are methodical, sometimes tedious work. You are mapping what is there. You're building a picture of the terrain. You're looking for anomalies, yes, but the expectation is usually that the anomalies will be modest. A sunken boat, a scatter of pottery, the outline of a submerged structure from a known historical period. What the sonar returned instead was something that did not fit any of those categories. A large, rounded, conical shape rising clearly from the flat southern basin floor, symmetrical in a way that the surrounding terrain was not, large in a way that immediately demanded attention. Follow-up dives confirmed it. The structure was real, physical, made of stacked basalt stones with no mortar, no cement, no binding material of any kind. Just stone on stone, carefully enough arranged to have held its general shape for what may be an enormous span of time. The divers who went down to look at it were working in difficult conditions. The water in the southern basin is murky, visibility is low, and the dark volcanic rock of the structure blends easily with the dark volcanic rock of the surrounding lake floor. Seeing it clearly, understanding its full extent from underwater, is genuinely hard. But the structure was unmistakably there. The findings were not published widely until 2013, when a paper appeared in the International Journal of Nautical Archaeology, formally describing the structure and its characteristics. That paper brought it to the attention of a broader scientific and public audience, and the reaction, at least in archaeological circles, was a mixture of careful fascination and genuine puzzlement. The structure did not fit neatly into any existing category. It was too large to dismiss, too unusual to explain quickly, and too poorly dated to confidently assign to any known cultural period. What is quietly remarkable about all of this is the question that sits just underneath the discovery itself. The Sea of Galilee has been one of the most continuously inhabited and intensively used bodies of water in the world for thousands of years. Fishermen have sailed its surface in every generation. Archaeologists have worked its shores and surrounding region for well over a century. Tourists visit in enormous numbers. Pilgrims come from around the world. The lake is not remote. It is not hidden. It is one of the more observed and documented places in the Middle East. And beneath all of that observation, in water shallow enough to dive without specialized equipment, a structure the size of a city block sat on the lake floor and was never formally recorded. That is not a failure of intelligence or attention. It is just a reminder of how much the surface of things can conceal. The lake looks like a lake. It looks like a place that has been understood. And in a sense it has been, but only the parts of it that were above the waterline, or near enough to it to be visible. The structure itself, sitting in its murky basin, was patient. It had been patient for a very long time. There is something worth pausing on here before we move into the details of what the structure actually looks like up close, how it was built, and what researchers have tried to understand about it. The Sea of Galilee is not a remote lake in an uninhabited wilderness. It is a lake surrounded by history, by continuous human presence, by centuries of careful attention. The fact that something this large could sit unnoticed, or at least unrecorded, in a place this well known is not a small thing. It tells you something about the limits of what we see, even when we are looking directly at a place. It tells you something about the difference between the surface of a story and what lies underneath it. The structure is about 230 metres across at its base. It rises to a height of roughly 12 metres. It is made entirely of basalt, the dominant volcanic rock of the region, stacked without any kind of mortar or adhesive. The individual stones vary in size. Some are small, some are quite large, but the overall shape is deliberate and consistent enough that geologists who have examined the sonar data and the dive footage agree. This is not a natural formation. The volcanic geology of the region produces basalt columns, basalt flows and basalt scatters, but it does not produce neat conical piles 230 metres wide. Something built this. Someone built this. When and why and who? Those are the questions that have no clean answers yet. And those are the questions we're going to spend the rest of this evening with. The discovery in 2003 was, in its own quiet way, the beginning of a much longer puzzle. This sonar image was striking. The dives confirmed the basic reality of what was there. But confirming that a structure exists is only the very first step. Understanding it, dating it, interpreting it, placing it within the human story of this region is a far more complicated and far slower process. And in the years since that first sonar return came back from the southern basin, progress has been real but limited. The structure has not given up its secrets easily. What we can do is start with the physical reality of it. Start with what it actually looks like, how big it really is when you try to picture it against things you know, and what the conditions are like for anyone trying to study it from below the waterline. Because before you can ask why something was built, you have to understand what it is you are actually looking at. And what you are looking at the bottom of the Sea of Galilee, is something that should not be there, or at least something that has no obvious explanation for why it is there. Which is, in its own way, the most interesting kind of thing to find in a place that everyone thought they already understood. So let us actually look at it. Not from the surface, not from a satellite image, but as close as the murky water of the southern basin will allow. The structure is a cone. That is the most basic description of it, and it is the right one. When researchers processed the sonar data from the 2003 survey, what came back was a roughly conical shape rising from the flat lake floor, wider at the base, narrowing as it climbs, not perfectly symmetrical the way a mathematical cone would be, but consistent enough in its form that the shape is unmistakable. It is not a pile. It is not a scatter. It is a deliberate accumulation of stone built upward with enough intention that the cone shape is held across what is likely a very long time indeed. The diameter at the base is approximately 230 metres. That number is worth sitting with for a moment, because it is genuinely difficult to picture. 230 metres is roughly the length of 2.5 American football fields placed end to end. It is wider than many city blocks. If you were to stand at one edge of the structure and look across to the other side, you would be looking at a distance of nearly 1/4 kilometre of stacked basalt stone. The footprint of a Boeing 747 is about 70 metres from wingtip to wingtip, so you could fit the wingspan of 3 of those aircraft across the base of this structure and still have room left over. It is, by any reasonable measure, an enormous thing. The height is around 12 metres. That is roughly 4 stories of a building. Not as dramatic as the diameter, perhaps, but when you consider that this is a pile of loose, uncemented stone that has been sitting underwater for potentially thousands of years, 12 metres of preserved height is significant. Stone cairns and mounds do settle over time. They spread. The fact that this one still rises 12 metres from the lake floor suggests either that it was originally considerably taller, or that the construction was dense and stable enough to resist significant collapse, possibly both. The total estimated weight is around 60,000 tonnes. That figure comes from calculating the volume of the cone and applying the density of basalt, which is a heavy rock, denser than granite, denser than sandstone, one of the heavier common rock types you will find anywhere. 60,000 tons of basalt. For comparison, the entire Stonehenge complex in England, all of its stones combined, the bluestones and the sarsens and the lintels, weigh somewhere in the range of 4,000 tons. The structure at the bottom of the Sea of Galilee contains roughly 15 times as much stone by weight as Stonehenge. That is not a comparison meant to suggest they are related in any way. It is just a way of anchoring the scale of what we are talking about. This is not a modest structure. It is not a local landmark built by a small community on a quiet afternoon. Whatever it is, it required an enormous amount of material and an enormous amount of effort. The stones themselves are basalt, the same dark volcanic rock that covers much of the surrounding landscape. The Golan Heights, the eastern shore of the lake, the volcanic plateau to the north and east. Basalt is everywhere in this part of the world. It is the local rock. It is what the land is made of, so the material of the structure is not exotic or imported. The builders, whoever they were, used what was around them. What is interesting is not the material but the quantity and the arrangement. The stones are stacked without mortar. There is no cement, no lime plaster, no adhesive of any kind holding them together. They sit on each other through weight and friction, and the careful fitting of one irregular surface against another. This is a style of construction that appears in megalithic sites across the ancient world, in the cairns of Scotland and Ireland, in the dry stone walls of the Levant, in the dolmens and burial mounds of the Bronze Age Middle East. It is a technique that works, when it is done well, for a very long time. The Sea of Galilee structure suggests it was done reasonably well. The individual stones vary in size. Some are relatively small, the kind of thing one person could carry or roll. Others are considerably larger, requiring significant effort to move and place. The mix of sizes is not unusual for this kind of construction. Larger stones tend to form the core and the base, providing stability, while smaller stones fill gaps and build the upper sections. The overall impression from the sonar data and from the dive footage that has been collected is of a structure that is rough but not random. There is an order to it. It is not a pile of rocks that happen to land in a cone shape. The cone is the result of deliberate stacking, repeated over what must have been a sustained period of construction. The structure sits in the southern basin of the Sea of Galilee, in water that ranges from roughly 9 to 16 metres deep depending on the current lake level, which fluctuates from year to year and has fluctuated far more dramatically over geological time. The southern basin is the shallower part of the lake. The northern basin drops to around 43 metres at its deepest, but the southern end is gentler, flatter and more accessible. In the context of underwater archaeology, 9 to 16 metres is not a great depth. Recreational divers work comfortably at those depths. The challenge at this site is not the depth, but the visibility. The water in the southern basin is murky. Sediment is easily disturbed. The dark basalt of the structure blends with the dark basalt of the surrounding lake floor in a way that makes it genuinely hard to see clearly, even when you're right next to it. Photographs taken at the site tend to show only a portion of the structure at any given time. A close-up of some stones here, a wider view of a section of the slope there. Getting a clear visual sense of the whole thing from underwater is effectively impossible. The sonar image gives you the shape, the dives give you the texture, neither gives you the full picture on its own. This is part of why the structure went unnoticed for so long, and it is worth thinking about that for a moment. The Sea of Galilee is not a deep, dark, cold lake where things can hide easily. It is a relatively shallow, relatively warm lake in one of the most historically active regions on Earth. It has been fished continuously for at least 3,000 years, probably longer. Boats have crossed it in every generation. Its shores have been settled, farmed, built upon, and excavated, and yet the structure in the southern basin, 230 metres wide, 12 metres tall, 60,000 tons of stone, was never formally recorded until a sonar survey in 2003 picked up its outline from above. The discovery is credited to Yitzhak Paz and Danny Nadel, archaeologists at the University of Haifa. Paz was leading the sonar survey as part of a broader effort to map the archaeological potential of the lake floor. It was not a targeted search for a megalithic structure. It was a general survey, the kind of baseline mapping that archaeologists do when they want to understand what a body of water might contain before committing to more intensive investigation. The sonar return from the southern basin was anomalous. The shape that came back did not match the flat sediment floor around it. It was too large, too regular, too elevated to be a natural feature of the lakebed. Follow-up dives confirmed what the sonar suggested. The structure was real, it was large, and it was made of stacked basalt stones arranged in a deliberate form. What is quietly remarkable about the sonar image itself is how clear the cone shape is when you look at it from above. From a bird's eye perspective, or a sonar perspective, which amounts to the same thing, the structure is obvious. The problem was always that no one had looked at the southern basin from above with the right instruments until 2003. Fishermen in boats do not see the lake floor. Swimmers see only the murk. Even early archaeological surveys of the lake focused primarily on the shoreline and the nearshore environment, not the deeper basin floor. The structure was hiding not because it was small or subtle, but because the angle of observation had never been right. There is something mildly humbling about that. We tend to assume that large things are easy to find, that scale makes things visible, but scale only helps if you are looking from the right direction, with the right tools at the right time. A 230-metre stone cone is invisible to a fisherman pulling nets from a wooden boat. It is invisible to a pilgrim standing on the shore. It is even invisible to a diver swimming across the lake floor in murky water, because the structure is too large to comprehend from inside it. You would just see rocks, dark rocks, the same dark rocks that cover much of the lake bed. The sonar gave Paz's team the distance, the elevation, and the perspective that made the shape legible. Without that tool, the structure might have remained unrecorded for considerably longer. And it is worth noting that the structure may in fact have been partially visible at certain points in history. The lake level of the Sea of Galilee is not fixed. It rises and falls with rainfall, with the flow of the Jordan River, and in more recent times with the management decisions of the Israeli national water carrier, which draws water from the lake for distribution across the country. During dry periods, the lake level can drop by several metres, and in those periods the shallowest parts of the southern basin come close to being exposed. There have been historical low water events during which the upper portion of the structure may have been at or near the surface. Whether anyone noticed it during those periods, and whether they understood what they were seeing if they did, is simply not known. No historical record has been found that clearly describes the structure. No ancient account mentions a cone of stones rising from the water in the southern basin. Either it was seen and not considered remarkable enough to write down, or it was seen and not recognised for what it was, or it was not seen at all. The silence of the historical record on this point is itself a kind of data, though it is hard to know exactly what it means. The physical reality of the structure then is this: a large, carefully stacked cone of basalt stones, approximately 230 metres wide and 12 metres tall, weighing around 60,000 tonnes, sitting in 9 to 16 metres of water in the southern basin of the Sea of Galilee. It has no mortar. It has no inscriptions. No artifacts have been recovered from inside it that would help date it. It blends with its surroundings in a way that makes it visually difficult to study from underwater, but its shape is unmistakable when viewed from above by sonar. It is the largest known prehistoric stone structure in the region, and possibly one of the largest in the world, depending on how you define the category, and it was sitting there, in a lake that millions of people have looked at and thought about and written about, completely unrecorded in the modern scientific literature until just over 20 years ago. That gap, between the structure's existence and its formal discovery, is one of the more interesting things about it. not because it suggests a cover-up or a mystery in the conspiratorial sense, but because it is a genuine reminder that the archaeological record is not complete, that we have not found everything, that even in well-studied places the ground, or in this case the water, still holds things we have not yet accounted for. Understanding the physical dimensions of the structure is the necessary starting point, but it raises an immediate and obvious question, which is, how exactly did researchers find it in the first place, and what happened in the moments and the years after that sonar image came back from the southern basin and someone looked at it and realised it was not just noise in the data? That story is worth telling carefully because it is not quite as simple as it might sound, and the path from anomalous sonar return to published scientific paper took considerably longer than you might expect. The survey that led to the discovery was not, at its origin, a search for anything dramatic. In 2003, a team from the University of Haifa undertook a sonar mapping project across the Sea of Galilee as part of a broader effort to document the lake's underwater archaeology. This kind of work had been happening in various forms around the lake for years, cataloguing anchors, mapping submerged shorelines, building a clearer picture of what the lake floor contained. The southern basin was included in the survey not because anyone expected to find something significant there, but because a systematic survey is systematic. You cover the area, you look at what comes back. Yitzhak Paz, an archaeologist with the Israel Antiquities Authority, who was working in collaboration with Danny Nadel of the University of Haifa, was part of the team conducting this work. Neither of them was hunting for a megalithic structure. There was no reason to expect one. The southern basin of the Sea of Galilee is not particularly famous for underwater finds. The northern areas of the lake, nearer Capernaum and Magdala, had drawn more archaeological attention over the years. The south was quieter, less studied, and in most working assumptions less likely to yield anything remarkable. The sonar return changed that assumption fairly quickly. When the data came back from the southern basin survey, one portion of it showed something that did not match the surrounding lake floor. The signal indicated a raised, roughly conical feature of considerable size. The sonar could not tell the researchers what the feature was made of, or how old it was, or whether it was natural or constructed. What it could tell them was the shape and the scale, and both were unusual enough to warrant a closer look. Follow-up dives were organised. Divers went down into the murky water of the southern basin and came back with a straightforward confirmation. The feature was real, it was large, and it was made of stacked basalt stones. Not a natural mound of sediment, not a geological extrusion from the lake floor. Stones stacked deliberately in a form that had not happened by accident. The initial reaction within the team was, by most accounts, cautious. Archaeologists working in the field tend to resist the pull of the dramatic conclusion, and for good reason. The history of archaeology contains more than a few examples of anomalous features that turned out to have mundane explanations. A sonar anomaly can be many things. Even a pile of stones can be many things. The researchers were careful in how they described what they had found, and careful in what they claimed about it. What they had, clearly, was a large stone structure on the lakebed. What it was, when it was built, and who built it, those questions were not answerable from the initial survey data alone, and the team did not pretend otherwise. What is interesting, and perhaps a little surprising, is how long it took for the discovery to reach a wider audience. The sonar survey was conducted in 2003. The follow-up dives confirmed the structure in the period shortly after. But the paper that brought the structure to the attention of the broader scientific and public community was not published until 2013, a full decade later. That paper, authored by Yitzhak Paz, Gideon Tibor, Gal Yassur Landau, Danny Nadel, and several colleagues, appeared in the International Journal of Nautical Archaeology. Its title was straightforward: a large stone structure on the bed of the Sea of Galilee. No dramatic framing, no claims about lost civilizations, just a careful, measured description of what the sonar had found, what the dives had confirmed and what the researchers thought it might be, along with an honest accounting of what they did not know. The decade between discovery and publication is not unusual in archaeology, particularly for underwater sites. Underwater excavation is expensive, logistically complicated, and subject to a range of regulatory and environmental considerations that do not apply to land sites in the same way. The Sea of Galilee is not just an archaeological resource, it is the primary freshwater reservoir for Israel, and any work conducted in it requires careful coordination with water authorities. Getting access, getting permits, organising dive teams, and conducting the kind of follow-up investigation needed to write a credible scientific paper takes time. The researchers were also presumably trying to understand what they had found before they wrote about it. Announcing a 60,000-ton stone structure in the Sea of Galilee is not the kind of thing you do carelessly. When the 2013 paper did appear, the academic reaction was, broadly speaking, a mixture of genuine curiosity and careful restraint. Archaeologists who work in the Levant were interested. The structure fit in some ways into a pattern of large-scale stone construction that was already known from the region. The dolmens of the Golan Heights, the basalt circles of the surrounding plateau, the enigmatic stone rings at Rujm el Hiri about 16 kilometres to the east. There was a context for large stone monuments in this part of the world, but the scale of the Galilee structure was still striking, even within that context, and the fact that it was underwater, in one of the most historically significant lakes in the world, gave it a particular quality that drew attention beyond the usual circles of Bronze Age specialists and nautical archaeologists. Some of the attention was less measured than the paper itself. News coverage of the discovery, which arrived again a decade after the actual sonar survey, tended toward the breathless. Headlines described it as a mysterious megalith, an underwater enigma, a structure that defied explanation. Some of the coverage implied that its existence was somehow inexplicable, that it posed a challenge to mainstream archaeology. None of that framing was really supported by the paper, which was careful and specific, and did not claim the structure was inexplicable, only that it was not yet fully explained. There is a difference, and it matters. The researchers had hypotheses, they had comparisons, they had a reasonable sense of the range of dates within which the structure was likely built. What they lacked was the kind of direct physical evidence, datable organic material from inside the structure, clear tool marks, associated artifacts, that would allow them to say with confidence what the structure was and when it was made. That is a scientific limitation, not a mystery in the supernatural sense. The question of why the structure was not formally recorded before 2003 is worth sitting with for a moment, because it is genuinely interesting and the answer is not entirely obvious. The Sea of Galilee has been fished continuously for thousands of years. It has been sailed, studied, written about, and visited by pilgrims, scholars and tourists in enormous numbers. Biblical accounts describe it in detail. Roman-era writers mentioned it. Medieval travellers crossed it. Modern archaeologists have worked along its shores for well over a century, and yet no one, in all of that time, produced a written record of a 230-metre stone cone sitting in the southern basin. How is that possible? Part of the answer is simply the nature of the lake environment. As described earlier, the structure is not visible from the surface under normal water conditions. The water in the southern basin is not clear enough to see the lake floor from a boat. Divers swimming across the structure would see dark rocks, the same dark basalt that covers much of the lakebed, without necessarily grasping that the rocks they were swimming over formed a coherent shape. The structure is too large to comprehend from inside it, at low visibility, without the benefit of a map or a sonar image to orient you. This is a real perceptual problem, not an excuse. But there is another part of the answer that is perhaps more interesting. The structure may have been seen at various points in history without being recognised. During low water periods, and the lake has experienced significant low water periods at various points in its history, the upper portion of the cone may have been at or near the surface, or even partially exposed. a cone of dark basalt rocks rising from the water or sitting just below it in the southern part of a lake that was not heavily trafficked in certain historical periods, might simply have been noted as a rocky shoal and avoided by fishermen who knew the lake well. Local knowledge of where not to take a boat does not necessarily translate into a formal archaeological record. People who live and work on a lake develop an intimate, practical understanding of its features without necessarily investigating or documenting those features in a way that survives into the modern period. It is also worth noting that underwater archaeology as a formal discipline is relatively young. The systematic use of sonar to map lake and sea floors for archaeological purposes became widespread only in the latter decades of the 20th century. Before that, what was known about the underwater archaeology of the Sea of Galilee was largely limited to what could be seen from the shore, what happened to wash up on the beach, or what was encountered incidentally by fishermen. The deliberate methodical survey of the lake floor with the kind of technology that could reveal a structure like this one simply had not been done before 2003. The absence of an earlier record is, in that light, less surprising than it might initially seem. It reflects the limits of the tools available, not a failure of attention or curiosity. There is one more element of the discovery story that is worth mentioning, and it concerns the lake level. In the years since the 2013 paper, the Sea of Galilee experienced a significant drought. By 2018, the lake had dropped to near record low levels. The water surface fell to roughly 214 metres below sea level, which is close to the historic minimum. At those levels, the southern basin becomes considerably shallower, and areas of the lake floor that are normally well submerged begin to approach the surface. The drought prompted renewed interest in the structure, partly because the lower water levels made it somewhat more accessible to divers, and partly because the dramatic images of a shrinking lake drew public attention to the region. Researchers took the opportunity to conduct additional observations. The structure was still there, of course. It was not going anywhere. But the low water conditions allowed for somewhat clearer documentation of its upper portions, and the renewed attention helped sustain scientific interest in a site that might otherwise have faded from public view after the initial wave of coverage in 2013. The lake has since recovered. A series of wet winters in the early 2020s brought the water level back up, and by some measures the lake returned to levels it had not seen in decades. The structure is once again sitting at its usual depth, in its usual murk, going about whatever it has been doing for however many thousands of years it has been down there, which, as far as we know, is simply existing. Waiting, if that is not too poetic a word for it, for someone to figure out what it is. What the discovery story illustrates more than anything else is that the archaeological record is genuinely incomplete in ways that are easy to underestimate. We tend to think of well-studied regions, and the area around the Sea of Galilee is about as well-studied as any region on Earth, given its historical and religious significance, as places where the major discoveries have already been made. Where what is left to find is detail and nuance, not something entirely new. The Galilee stone structure is a reminder that this assumption is wrong, not because there are lost civilizations hiding under every lake, but because the tools available for investigation change over time, and what was invisible to one generation of researchers can become perfectly clear to the next. Sonar made this structure legible. Without sonar, it would still be an anomaly that no one had formally described. The discovery itself, then, is really a story about the relationship between technology and knowledge, about how what we see depends on how we look, and how looking from the right angle, in this case from directly above, with acoustic instruments capable of mapping the lake floor, can reveal something that was always there but never properly seen. That is a slightly humbling idea, and also a quietly exciting one. If the southern basin of the Sea of Galilee was holding a 60,000-ton stone structure that no one had formally documented until 2003, it raises a reasonable question about what else might be sitting, unrecorded, in the floors of other lakes, or in the shallows of coastlines that have not yet been systematically surveyed with modern tools. But before getting too far into that broader question, it is worth understanding the physical and geological setting of the Sea of Galilee itself more carefully. Because the structure does not exist in a vacuum. It exists in a specific landscape made of specific materials in a region that has a very particular geological character. And understanding that character is essential to understanding both why the structure is made the way it is and why the question of whether it is natural or constructed is one that had to be addressed seriously before any other interpretation could move forward. The Sea of Galilee sits inside one of the most geologically dramatic landscapes on the surface of the Earth. That is not an exaggeration. The lake occupies a depression in the Jordan Rift Valley, which is itself part of the Great Rift Valley system, a vast geological scar that runs from the Afar Triangle in eastern Africa all the way north through the Red Sea, up through the Gulf of Aqaba and into the Levant, eventually connecting to a series of fault systems that extend into southern Turkey. The section of this rift that runs through modern Israel and Jordan is one of the most tectonically active parts of the entire system. The ground here has been pulling apart, subsiding and shifting for millions of years. The Sea of Galilee, sitting at roughly 209 meters below sea level in normal conditions, is itself a product of that slow geological violence. The land dropped, water filled the depression, a lake was born. The Rift Valley also brought something else to the surface, or rather pushed it up through the surface: volcanic rock. The Golan Heights, which rise to the east of the lake, are essentially a basalt plateau, the remnant of extensive volcanic activity that occurred over millions of years and continued in some areas into relatively recent geological time. The hills to the north and northeast of the lake are dark and heavy with volcanic material. If you drive through this landscape, the colour of the rock is immediately striking. It is not the pale limestone you see in much of the Mediterranean world. It is dark grey, almost black in places, dense and heavy, with a rough, almost granular texture. Basalt. It is everywhere. It is the dominant building material of the region, not because ancient people made a sophisticated choice, but simply because it was what the ground offered them. You build with what is nearby. This matters enormously for understanding the stone structure on the lake floor. The basalt blocks that make up the cone are not exotic or imported material. They did not have to be carried from distant mountains or floated across seas. The nearest basalt outcrops to the southern basin of the Sea of Galilee are relatively close. The eastern shore of the lake and the lower slopes of the Golan Plateau are within a few kilometres. In a region where people were already accustomed to working with basalt, grinding stones, building terraces, constructing walls and cairns, the material for a structure like this one was simply available. That does not make the construction trivial. Moving 60,000 tons of rock, even locally available rock, is an enormous undertaking by any measure. But it does remove one of the more dramatic elements that sometimes gets attached to megalithic mysteries. The idea that the builders must have had some extraordinary technology to transport materials across vast distances. In this case, they did not need to. The stone was there. The question is not where it came from. The question is who moved it, and why, and when. The volcanic history of this region is also relevant in another way, because it is the reason that the question of natural versus human-made had to be taken seriously when the structure was first described. Volcanic landscapes produce strange formations. Basalt columns, lava tubes, volcanic cones, irregular mounds of cooled lava. These are all features that can, under certain conditions, resemble constructed structures, at least superficially. The geological record of the Golan Heights and the Jordan Valley includes all kinds of volcanic landforms, some of which are genuinely unusual in shape. So when a sonar survey returns an anomaly in the shape of a large cone sitting on the floor of a lake in a volcanic region, the first serious question a scientist has to ask is, could this be natural? The researchers who examined the structure addressed this question carefully, and their answer was no. The basis for that conclusion rests on several observable features of the structure itself. First, the stones are stacked. They're arranged in a way that reflects deliberate placement, not the random tumble of volcanic ejecta or the irregular cooling patterns of a lava flow. Basalt, when it cools naturally, tends to form columns or irregular masses, not neat piles of roughly similar-sized rocks arranged in a conical heap. Second, the shape of the structure is too regular to be a natural volcanic feature. A volcanic cone produced by eruption typically has a crater at the top and a specific internal structure that reflects the way lava and ash accumulated. This structure has neither. It is a solid cone of stacked rocks, not a volcanic edifice. Third, the size and concentration of the stones in one location, without any corresponding geological feature that would explain their presence there, points to deliberate collection and placement. The basalt blocks did not simply end up in a neat pile by accident. Someone put them there. Geologists who have reviewed the available data have been consistent on this point. The structure is not a natural formation. That conclusion, while it sounds simple, is actually an important step in the scientific process because it closes off a significant alternative explanation and forces the question firmly into the human domain. Whatever this thing is, people made it. That much is established. Now, the lake-level history is a separate but closely related piece of the geological picture, and it is worth spending some time with it, because it has direct implications for when the structure might have been built and what the landscape around it looked like at the time of construction. The Sea of Galilee is a closed freshwater lake. It has an inflow from the Jordan River in the north and an outflow through the southern Jordan in normal conditions, but its level is highly sensitive to rainfall, evaporation, and human water use. In the modern period, the lake has been managed as a critical water resource for Israel, and its level is maintained within a relatively narrow range. But over geological and historical time, the lake's level has fluctuated considerably. During the last glacial maximum, roughly 20,000 years ago, the climate of the Levant was significantly different from today. Cooler, and in some periods wetter, in others drier. Lake levels across the region responded to these shifts. The Sea of Galilee was sometimes higher than it is now, sometimes lower. There are periods in the geological record when the lake may have been substantially lower than its current level. Low enough that the southern basin, where the structure sits, could have been dry land or very shallow wetland rather than open water. This is not a fringe idea. It is supported by sediment cores and by the known behaviour of other lakes in the region, including the Dead Sea to the south, which has its own well-documented history of dramatic level changes. If the southern basin was dry land during the period when the structure was built, then the construction scenario looks very different from what you might imagine when you picture someone building something underwater. The builders would not have been working in water at all. They would have been standing on dry basalt ground, stacking rocks in the open air, in a landscape that might have looked something like the current eastern shore of the lake, rocky, volcanic, warm, with the lake visible not far away. The structure would have been a surface feature, fully visible, perhaps even prominent in the landscape. At some later point, as the lake level rose, whether due to a wetter climate, a regional hydrological shift or some combination of factors, the structure would have been gradually submerged, not in a dramatic flood most likely, but slowly, over decades or centuries, until it was fully underwater and effectively invisible to anyone standing on the shore. This scenario fits the available evidence reasonably well, and it has important implications for the dating question, which we'll come to more fully in a moment. But it also helps explain something that might otherwise seem puzzling. Why would anyone build a large stone structure in a lake? The answer, most likely, is that they did not. They built it on land, and the lake came later. The tectonic setting adds one more layer to this picture. The Jordan Rift Valley is seismically active. Earthquakes have occurred in this region throughout recorded history, and the geological record shows evidence of significant seismic events going back much further. The region around the Sea of Galilee has experienced major earthquakes. There was a significant one in 749 CE that caused widespread destruction across the Galilee and Jordan Valley, and historical records mention others. Tectonic activity can cause ground subsidence, which could in theory contribute to changes in local topography and lake level. It is possible, though difficult to quantify, that seismic events played some role in the submersion of the structure, either by directly lowering the ground on which it sits, or by contributing to broader hydrological changes in the basin. None of this changes the fundamental character of the structure. It is still a human-made pile of basalt rocks in the shape of a cone sitting on the floor of a lake, but the geological context gives that fact a richer setting. The structure did not appear in a stable, unchanging landscape. It appeared in a landscape that was and continues to be geologically alive, shifting, subsiding, flooding, drying, reshaping itself over time. The people who built it were living in a world that looked quite different from the one we see today, and the fact that their construction has survived all of that geological activity, the rising water, the earthquakes, the millennia of sediment accumulation, is itself somewhat remarkable. There is also the matter of what the surrounding landscape offered in terms of resources during the likely construction period. The Jordan Valley and the shores of the Sea of Galilee were not empty or marginal places in prehistoric times. The region has fresh water, fertile soil in the valley floor, fish in the lake, and game in the surrounding hills. It was, by the standards of the ancient Near East, a productive and attractive place to live. Archaeological sites from the Neolithic and Chalcolithic periods, roughly 10,000 to 5,000 years ago, have been found throughout the Jordan Valley and the Galilee region. People were here. They were farming, herding, fishing and building. The basalt landscapes of the Golan Heights are dotted with ancient structures, dolmens, cairns, agricultural terraces, field walls, that demonstrate a long tradition of working with the local stone in substantial ways. The Galilee stone structure fits into that broader tradition, even if it is larger and more puzzling than most of what has been found in the region. The basalt itself as a material is worth a brief note. It is heavy, significantly heavier than limestone or sandstone. A cubic metre of basalt weighs roughly 3 tons, compared to about 2.5 tons for limestone. That density is part of why the total estimated weight of the structure is so large, despite its relatively modest height of about 12 metres. The stones are not just numerous, they are individually heavy. Moving them without metal tools, without wheeled vehicles, without draft animals in any organised way, all of which are possibilities depending on the construction date, would have required an enormous amount of human physical effort. The logistics of this are genuinely impressive to think about. Not impossible, but impressive. And that impression only deepens when you start to ask not just how the stones were moved, but why anyone felt it was worth the effort to move them in the first place. That question, the purpose of the structure, is one that the geological and physical context can only partially answer. The geology tells us what the structure is made of, where the material came from, and something about the conditions under which it was built. It tells us that the construction was deliberate and substantial, but it does not tell us what the builders intended. For that, we have to look at a different kind of evidence, the dating of the structure and what the date implies about who was living in this region and what they were doing. And the dating question, it turns out, is one of the most genuinely difficult aspects of this entire mystery. So let us stay with the dating question for a while, because it deserves more than a passing mention. It is genuinely one of the most frustrating and fascinating aspects of this structure, and the difficulty is not a failure of science. It is a reflection of the real limits that archaeologists face when dealing with a site like this one. The most reliable method for dating ancient organic material is radiocarbon dating. You find something that was once alive, a piece of charcoal from a fire, a fragment of bone, a seed, a piece of wood, and you measure how much of its carbon-14 has decayed. The math gives you an age, usually with a margin of error of a few decades to a few centuries, depending on the material and the period. It is not perfect, but it is direct. It gives you something to hold on to. The problem with the Galilee stone structure is simple. No organic material has been recovered from inside it, or from a clearly associated layer beneath it. The stones are basalt. Basalt does not contain carbon-14 in a form that can be meaningfully dated by standard radiocarbon methods. The gaps between the stones have been filled, over time, with lake sediment, silt, clay, fine particles that have drifted down through the water column over however many centuries the structure has been submerged. That sediment contains organic material potentially, but sediment is tricky. It accumulates continuously, and material from different periods can mix together. A seed that washed into the structure 200 years ago tells you nothing reliable about when the structure was built. So the researchers who have studied this site have had to work with indirect methods, and indirect methods require a different kind of patience. One approach is to look at the sediment stratigraphy around the base of the structure, the layered sequence of deposits that have accumulated on the lake floor over time. If you can identify the layer of sediment that was present when the structure was built, and if that layer contains datable material, you can get a minimum age for the construction. The structure must be at least as old as the layer it sits on. This kind of analysis requires careful coring, drilling down through the sediment in controlled increments and analysing each layer. It has been done in the vicinity of the structure, but the results have been inconclusive in terms of producing a clear construction date. The sediment record in the southern basin of the Sea of Galilee is complicated by the lake's fluctuating water levels, which means the depositional history is not a simple continuous record. There are gaps, erosional episodes, layers that were disturbed by periods of low water or increased wave action. Reading it clearly is genuinely hard. Another indirect approach is to look at the lake's water level history and work backward. If the structure was built on dry land, which most researchers believe is the most plausible scenario, then it must have been built during a period when the lake level was low enough to expose the southern basin floor, where the structure now sits. The structure sits at a depth of roughly 9 to 16 metres depending on exactly where you measure. For the lake to have been that much lower than its current level, you need to go back a significant amount of time. Paleohydrological studies of the Sea of Galilee and the Jordan River system have reconstructed rough water level histories using sediment cores, pollen records, and isotopic analysis. These studies suggest that the lake has indeed been substantially lower than its current level at various points in the past, during dry periods in the Middle Holocene, for example, and possibly during the late Pleistocene and early Holocene, when the regional climate was undergoing significant transitions after the last ice age. But these reconstructions have their own uncertainties, and matching them precisely to the depth of the structure is not straightforward. What researchers have been left with then is a range, a wide one. Current estimates for the construction date span from roughly 2,000 to 12,000 years ago. That is a 10,000-year window, which, to put it gently, is not a precise answer. Within that range, different researchers have favoured different periods based on different lines of reasoning. Some have pointed to the early Bronze Age, roughly 5,000 to 4,500 years ago, as the most likely period, based on comparisons to other megalithic construction in the region, and what is known about the social complexity of communities living around the Sea of Galilee at that time. The early Bronze Age in the Levant was a period of growing urban organisation, of walled towns, of large communal building projects. It is not implausible that a community with Bronze Age organisational capacity could have built something like this. Others have suggested a Neolithic date, which would push the construction back to somewhere between 10,000 and 5,000 years ago. The Neolithic in the Levant is the period of the earliest farming villages, of communities beginning to settle permanently, of the first stirrings of what we might call organised landscape modification. Göbekli Tepe in southeastern Turkey, which dates to roughly 11,000 years ago, demonstrated conclusively that Neolithic communities were capable of large-scale coordinated stone construction long before anyone expected them to be. If the Galilee structure is Neolithic, it would fit into a slowly growing picture of early monumental activity in the broader Near East. Some researchers find this possibility genuinely exciting. Others are more cautious, noting that the evidence for a Neolithic date is thin and that the early Bronze Age remains a more comfortable fit with what is currently known. There is also a Chalcolithic possibility, the Chalcolithic period, which runs roughly from 6,500 to 5,000 years ago, sits between the Neolithic and the Bronze Age, and represents a transitional phase in which copper was beginning to be used alongside stone. Chalcolithic communities in the Levant were building large structures, engaging in long-distance trade, and organising themselves in increasingly complex ways. The famous Rujm el-Hiri, the large stone circle on the Golan Heights about 16 kilometres from the lake, is believed by many researchers to date primarily to the early Bronze Age with possible Chalcolithic antecedents. If the Galilee structure is contemporaneous with Rujm el-Hiri, it would fit into a regional pattern of large basalt construction during roughly the same broad period. The honest answer is that we do not know. And the uncertainty itself is meaningful. It is not just an inconvenience or a gap waiting to be filled. It reflects the fact that the structure has not been formally excavated, that the underwater environment makes standard archaeological methods difficult to apply, and that the site has not received the kind of sustained, well-funded research attention that would be required to resolve these questions. The 2013 paper in the International Journal of Nautical Archaeology, which brought the structure to wider academic attention, is still essentially the primary published scientific source on the site. Follow-up work has been limited. The structure floats in time, as one researcher put it, a phrase that feels almost too apt given that it is literally sitting on the floor of a lake. What makes the dating uncertainty particularly interesting is that it is not simply a technical problem. The date of the structure changes its meaning in fundamental ways. If it is 2,000 years old, it belongs to a period of well-documented historical activity in the Galilee. The Roman period, the Hellenistic period, the Iron Age. Communities living around the lake at that time were sophisticated, literate in some cases, connected to broader Mediterranean and Near Eastern networks. A 2,000-year-old structure would be impressive, but it would not necessarily be surprising in terms of what it implies about the builder's organisational capacity. If it is 5,000 years old, it belongs to the early Bronze Age, and it becomes a significant example of monumental construction in a period that is well represented archaeologically in the region, though still not fully understood. If it is 8 or 10,000 years old, it becomes something else entirely. A monument built by people who were, in the conventional understanding of prehistory, not yet supposed to be building monuments on this scale. It would place the Galilee structure in the same extraordinary category as Göbekli Tepe, as evidence that the transition to complex social organisation happened earlier and more variably than the textbook version of history suggests. This is why the dating question is not just a technical detail, it is the central question. The structure's physical reality, 60,000 tons of basalt stacked in a cone shape, sitting on the floor of a famous lake, is striking regardless of when it was built. But the date determines the story. It determines who the builders were, what kind of society they lived in, what resources and knowledge they had access to, and what the existence of this structure implies about the broader history of human civilization in the Levant. Without a firm date, all of those questions remain genuinely open. Researchers have tried to use the comparison to other regional sites as a rough guide. The dolmens of the Golan Heights, large stone burial structures scattered across the basalt plateau, have been dated in some cases to the Chalcolithic and early Bronze Age. The construction tradition they represent is real and documented. The Galilee structure, if it belongs to the same tradition, would fit into a known cultural context. But the Galilee structure is substantially larger than any individual dolmen, and its form, a cone rather than a chamber, is different enough that direct comparison has limits. It is possible it represents a variation on a known tradition, or it is possible it represents something else entirely that does not fit neatly into any existing category. There is also the question of what the lake level history can tell us more specifically. Paleohydrological data suggests that the Sea of Galilee experienced significantly lower water levels during the early to middle Holocene, roughly 10,000 to 5,000 years ago, as the regional climate transitioned from the wetter conditions of the late Pleistocene toward the drier patterns of the mid-Holocene. During some of these periods, the southern basin may have been considerably shallower or even partially dry. If the structure was built during one of these low water episodes and then submerged as the lake refilled during a subsequent wetter period, that would suggest a construction date somewhere in the broad range of the Neolithic to early Chalcolithic. This is speculative, but it is not arbitrary speculation. It is grounded in real data about how the lake has behaved over time. One thing that researchers generally agree on is that the structure was not built underwater. Building a coherent cone of loosely stacked basalt stones at a depth of 9 to 16 metres without modern diving equipment would be essentially impossible. The structure must have been built on land, or at most in very shallow water at the lake's edge. That constraint, combined with the current depth of the structure, sets a real lower bound on how long ago the lake must have risen to cover it. The lake would have had to be substantially lower than it is today, and that condition has not existed during the historical period in any documented way. This pushes the construction date back, at minimum, into the prehistoric period, though exactly how far back remains the question. What the dating uncertainty leaves us with ultimately is a structure that is genuinely difficult to place. It is large enough and deliberate enough that it clearly required significant human effort and organisation. It is old enough that the people who built it left no written record of what they were doing or why. It is submerged in a lake that has been continuously used and observed for thousands of years, yet it went unrecorded until modern sonar found it. And the tools that archaeologists would normally use to pin down its age have not so far yielded a clear answer. The structure sits in its cone shape on the lake floor, patient and unhurried, indifferent to the uncertainty it creates. It has been waiting in the dark water for a very long time. It can wait a little longer. But what the comparison to other megalithic structures in the region begins to suggest, and this is where the story opens up in an interesting direction, is that the Galilee structure may not be as isolated as it first appears. To understand why the Galilee structure feels significant beyond its own physical presence, it helps to step back and look at the broader landscape it belongs to. Not just the southern basin of the lake, not just the Jordan Rift Valley, but the wider region of the Levant, a stretch of land that has been for a very long time one of the most densely layered archaeological zones on the planet. And when you look at that landscape with the Galilee structure in mind, something becomes clear fairly quickly. The people who may have built this cone of basalt were not working in a cultural vacuum. They were part of a world that, in certain periods, was actively building large things out of stone. The comparison that gets mentioned most often, at least in popular discussions of the structure, is Stonehenge. It is an easy comparison to reach for. Stonehenge is the most famous megalithic monument in the world. It is made of massive stones arranged with deliberate precision, and it has an air of mystery that makes any comparison feel appropriate. But the comparison is actually more interesting for what it reveals about scale than for any deeper similarity. Stonehenge in total weighs somewhere in the range of 4,000 tons. The Galilee structure, by the current estimate, weighs around 60,000 tons. That is not a small difference. The Galilee structure is roughly 15 times heavier than Stonehenge. If you stacked the entire weight of Stonehenge 15 times over, you would be approaching what sits on the floor of this lake. Stonehenge is rightly considered one of the great engineering achievements of prehistoric Europe. The Galilee structure, in terms of raw mass, dwarfs it considerably. That is worth sitting with for a moment, because it is easy to let numbers slide past without really feeling them. Of course, weight is not the only measure of complexity or significance. Stonehenge involved the transport of bluestones from Wales, more than 200 miles away, which represents a logistical challenge of an entirely different kind. The Galilee structure, by contrast, appears to have been built from local basalt, stone that was likely available relatively close to the construction site, given how thoroughly basalt dominates the geology of the surrounding region. In that sense, the builders of the Galilee structure may have had an easier time sourcing their material, but 60,000 tons of any rock, moved and stacked into a deliberate shape, is still an enormous undertaking regardless of how far the stones travelled. The cairns of Scotland offer a closer parallel in some ways. A cairn, in the broadest sense, is a mound of stones, sometimes covering a burial, sometimes marking a landscape feature, sometimes serving purposes that are not fully understood. Scotland has hundreds of them, ranging from small roadside markers to substantial monuments, like the Clava Cairns near Inverness, which date to around 2000 BCE and involve carefully arranged rings of standing stones surrounding central burial chambers. The Galilee structure, if it is indeed a cairn of some kind, would belong to a tradition that was genuinely widespread across the ancient world. People building mounds of stone for reasons that clearly mattered deeply to them, even if those reasons varied from place to place and period to period. The form is ancient and almost universal. What makes the Galilee structure unusual within that tradition is its size, its submersion, and the almost complete absence of associated finds that might clarify its purpose. But the most directly relevant comparisons are not in Scotland or England. They are much closer. Within a relatively short distance of the Sea of Galilee, the landscape is scattered with megalithic structures that share some of the same basic characteristics. Large basalt stones, deliberate arrangement, uncertain or debated purpose, and a construction tradition that flourished during the Chalcolithic and early Bronze Age periods. The dolmens of the Golan Heights are perhaps the most numerous example. These are large stone burial structures, typically a flat capstone supported by upright stones, forming a chamber, and they appear across the basalt plateau in significant numbers. Some estimates put the total number of dolmens in the Golan region at several thousand, though many have been damaged or destroyed over the centuries. They vary considerably in size, but the largest are substantial constructions, requiring the movement of multi-ton stones. They have been dated, in cases where organic material was recovered, to the Chalcolithic period and the early Bronze Age, roughly 4,000 to 6,000 years ago. They represent a real and documented tradition of a large-scale stone construction in this specific region, using the same material, basalt, that the Galilee structure is made of. What this suggests is that the Galilee structure, whatever its exact date, was not built by people who had no experience with moving large stones. If it belongs to the same broad cultural tradition as the Golan dolmens, then it was built by communities for whom working with basalt on a large scale was a known practice, not an unprecedented leap. The logistics were presumably familiar, at least in principle, even if the Galilee structure represents a scale that goes well beyond any individual dolmen. That context matters. It shifts the structure from something completely inexplicable to something that, while still deeply puzzling, fits into a recognisable pattern of human behaviour in this region during certain periods. And then there is Rujmelhiri. If you travel roughly 16 kilometres northeast of the Sea of Galilee, up onto the basalt plateau of the Golan Heights, you reach one of the most remarkable and least visited megalithic sites in the world. Rujmelhiri, which translates roughly from Arabic as the stone heap of the wild cat, though it is also sometimes called Gilgal Rephaim, meaning the wheel of the giants, in Hebrew, is a series of concentric stone circles surrounding a central cairn. The outermost ring is approximately 160 metres in diameter. The total weight of the stone involved is estimated at around 40,000 tonnes. It was built based on available dating evidence sometime between roughly 3000 and 2700 BCE, placing it in the early Bronze Age. Its purpose is debated. Astronomical alignments have been proposed, as have theories involving ritual use or territorial marking. but no single explanation has achieved consensus. Sound familiar? The parallel between Rujum El Hiri and the Galilee structure is striking enough that researchers have noted it directly. Both are large-scale basalt stone constructions in the same region. Both have uncertain purposes. Both date, at least in the favoured estimates, to a similar broad period. Both required a level of organised labour that implies a community with significant surplus capacity and some form of coordinating authority. Rujum El Hiri is on dry land and has been studied more extensively, but it too remains poorly understood in fundamental ways. The fact that two such structures exist within 16 kilometres of each other, one on the plateau, one on the lake floor, is not something that researchers treat as coincidence. It suggests that whatever culture or cultures were active in this region during the relevant period had both the means and the motivation to build on a large scale, and that the Galilee structure may be one expression of a broader tradition of monumental construction that was more widespread here than is commonly appreciated. There is also a pattern worth noting in how these structures relate to the landscape. Rujum El Hiri sits on high ground with long sight lines across the plateau. The Galilee structure, if it was built on land before the lake rose, would have sat near the edge of a significant body of water, or perhaps at a location where the lake's southern basin was shallower or partly exposed. Large stone monuments in many cultures tend to be placed at significant landscape features: hilltops, river crossings, lake shores, boundaries between different terrain types. Whether the Galilee structure was built at the lake's edge or on what was then dry ground that later flooded, its relationship to the water may have been intentional. That is speculative, but it is a reasonable kind of speculation, given how consistently ancient monument builders across many cultures paid attention to where they placed their constructions. The broader megalithic tradition of the Levant extends beyond just the Golan and the Galilee. The region as a whole has a long history of large-scale stone construction that predates the well-known monuments of Egypt and Mesopotamia in some cases. The Nasufian culture, which flourished in the Levant from roughly 15,000 to 11,500 years ago, built semi-permanent settlements with stone foundations. Some of the earliest evidence of sedentary or semi-sedentary life anywhere in the world. The pre-pottery Neolithic period that followed saw the construction of Jericho's stone tower, which dates to around 8000 BCE and is one of the oldest known large stone structures on Earth. Göbekli Tepe in southeastern Turkey, dating to roughly 9600 BCE, rewrote assumptions about what Neolithic communities were capable of building. The Levant and the surrounding region was, in other words, a place where large-scale stone construction happened early and repeatedly. The Galilee structure, even at its most conservative estimated age, fits into a world that was already building seriously. What makes it stand out within that world, though, is still its scale. The Golan dolmens are numerous but individually modest compared to 60,000 tons. Rujum El Hiri is large and impressive, but at 40,000 tons it is still substantially smaller. Even within a region that has a genuine tradition of megalithic construction, the Galilee structure is the heaviest known example. That distinction is not trivial. It means that whoever built it was either working within a tradition but pushing it to an unusual extreme, or was doing something categorically different that happened to use similar materials. Both possibilities are interesting in different ways. There is also something worth noting about what the comparison to regional sites does not resolve. The existence of dolmens on the Golan and the presence of Rujum El Hiri nearby makes it plausible that the Galilee structure was built during the Chalcolithic or early Bronze Age by communities with documented stone building traditions. But plausibility is not proof. The structure could still be older, Neolithic or even earlier, in which case it would predate the Golan dolmens and Rujum El Hiri by several thousand years, and would represent something more unusual in terms of what it implies about the organisational capacity of the people who built it. The regional comparisons help set a context, but they do not close the question. They suggest a family of possibilities rather than a single answer. It is also worth pausing on the fact that the Galilee structure is underwater, while its regional cousins are not. That difference in preservation environment is significant. The dolmens of the Golan have been accessible to researchers for generations. They have been mapped, measured, excavated in some cases, and incorporated into the archaeological record in ways that the Galilee structure has not. Rujm el Hiri has been surveyed extensively from the air and on the ground. The Galilee structure, by contrast, sits under 9 to 16 metres of murky lake water, accessible only by divers working in low visibility conditions, surrounded by sediment that complicates any attempt at systematic excavation. Its submersion is the reason it remained unknown for so long, and it is the reason it remains so poorly understood today. In a landscape full of megalithic sites, this one has had the misfortune, or perhaps the fortune depending on how you look at it, of being hidden in a place that made it almost impossible to study, and yet the hiding place has also preserved it in a certain way. Stone structures on the surface of the Golan have been exposed to millennia of weathering, agricultural activity, military conflict. The Golan Heights has seen a great deal of that, and human disturbance of various kinds. The Galilee structure, sitting on the lake floor, has been largely protected from all of that. The sediment that has accumulated around its base is an inconvenience for dating purposes, but it may also have protected the lower portions of the structure from the kind of disturbance that has affected surface sites. What condition the interior of the structure is in, whether there is anything preserved within it, remains genuinely unknown. No one has yet been able to look carefully enough to say. What the regional comparisons ultimately suggest is that the Galilee structure is not an anomaly in the sense of being completely without precedent. It belongs to a world that was building with stone, and building large, for a very long time. The Levant was not a backwater of prehistoric culture. It was, in many respects, one of the most active zones of early human innovation and social development on the planet. The Galilee structure fits into that world, even if it sits at the outer edge of what that world is known to have produced in terms of scale. It is the largest and the least understood and the most inaccessible, but it is not alone, which raises the next question naturally. If the structure fits into a regional tradition of large-scale stone construction, and if the builders had the organisational capacity and the cultural motivation to build on this scale, then what specifically were they building it for? The comparison to cairns and stone circles and ritual platforms gives us a range of possibilities, but each of those possibilities, when you look at them carefully, comes with its own complications. So let us look at those possibilities carefully, because they deserve more than a quick summary. The question of purpose is in many ways the most human question you can ask about the structure. The size, the weight, the labour, those are impressive facts. But purpose is what connects the structure to the people who built it. It is what turns a pile of stones into a story. The most commonly cited explanation, and the one that appears most frequently in the academic literature, is that the structure is a cairn, a burial monument, a large heap of stones placed deliberately over a grave or a series of graves in the tradition that was practiced across the Levant and much of the ancient world. This is a reasonable starting point. Cairns are among the most widespread forms of monumental construction in human prehistory. They appear in Scotland, in Ireland, in Scandinavia, across the Middle East, across Central Asia. The impulse to mark death with stone, to make it permanent, to give it weight, is one of the oldest impulses we know of, and cairns in this region are not rare. The Golan Heights alone contains thousands of dolmens, many of which are essentially cairns in structure, stones stacked over a burial chamber. The idea that the Galilee structure is a very large version of something that was being built all around it is not unreasonable, but the cairn theory has a problem. And the problem is simple. No burial evidence has been found inside the structure. No bones, no grave goods, no burial chamber, no arrangement of stones consistent with the kind of internal architecture you would expect in a mortuary monument. Now, it is fair to point out that the interior of the structure has not been fully investigated. The conditions for underwater excavation at this site are genuinely difficult, and no systematic excavation has taken place. So the absence of burial evidence is not the same as proof that no burial evidence exists. It is possible that a burial chamber sits at the centre of the structure, beneath meters of accumulated sediment, undisturbed and undiscovered. That is possible. But it is also possible that there is nothing there. The cairn theory is plausible in a regional context, but it remains unconfirmed in any direct sense. It is a hypothesis that fits the landscape without yet fitting the evidence. The second major hypothesis is that the structure served as a fish trap. This one is interesting because it is practical rather than ceremonial. The Sea of Galilee has been a fishing resource for as long as people have lived near it. Ancient fish traps made of stone are known from other parts of the world. They were built in tidal zones along coastlines, in rivers, in shallow lake margins. The basic principle is that fish swim into an enclosure and cannot easily swim back out. Stone walls, stone weirs, stone channels. These are all attested in the archaeological record, and the southern basin of the Sea of Galilee, where the structure sits, would have been a reasonable location for a large fishing installation during periods when the water was shallower or the structure was close to the surface. But the fish trap theory has structural problems. When researchers looked at the design of the Galilee structure, a solid cone of stacked basalt stones, roughly 12 metres tall and 230 metres across at the base, it does not match the architecture of known ancient fish traps. Fish traps work by creating enclosed spaces with controlled entry and exit points. They are typically open, channeled structures with gaps and passages designed to guide fish movement. The Galilee structure, as far as can be determined from sonar and diver observation, is a solid mass. It does not have the internal channels or enclosure walls that a fish trap would require. The shape is wrong for the function. A cone of 60,000 tons of solid basalt is not a practical fishing installation. It is too massive, too solid, and too deep in the water to have served that purpose effectively. Most researchers who have looked at this seriously have moved away from the fish trap idea, though it occasionally reappears in popular coverage of the site. The third possibility is that the structure was a ritual or ceremonial platform of some kind. This is more speculative, and researchers who propose it are generally careful to say so. But it fits a regional pattern that is genuinely hard to ignore. Rujim El Hiri, the large basalt stone circle on the Golan Plateau about 16 kilometres from the lake, is widely believed to have had a ritual or ceremonial function, though its exact purpose is also debated. The dolmens of the Golan, while primarily mortuary in character, were also embedded in a broader cultural landscape of stone monuments that likely had social and symbolic significance beyond simple burial. Large stone constructions in this region were not purely utilitarian. They carried meaning. They marked territory. They expressed collective identity. They oriented communities in space and time. A ceremonial platform built on or near the shore of the Sea of Galilee during the Chalcolithic or early Bronze Age would fit that cultural context reasonably well. The lake itself may have had religious or cosmological significance for the communities that lived around it. Water sources in arid and semi-arid regions often do. A large stone platform at the edge of or within the lake could have served as a place of gathering, of ritual activity, of communal ceremony. The problem, of course, is that this explanation is difficult to test archaeologically. Ritual use leaves behind a different kind of evidence than habitation or burial. Sometimes it leaves almost nothing at all, especially in an underwater environment where organic materials and portable objects would long since have dispersed or deteriorated. The ceremonial platform hypothesis is coherent, but it is not provable with the evidence currently available. There is a fourth idea that comes up less frequently, but is worth considering. Some researchers have suggested that the structure might have been a navigational marker or a territorial boundary marker of some kind. The Sea of Galilee, even in antiquity, was a body of water that communities navigated regularly, for fishing, for trade, for movement between settlements on its different shores. A large stone structure visible from the water, or knowable to those who fished the southern basin, could have functioned as a landmark, something that told fishermen where they were or marked the boundary between one community's fishing territory and another's. This is speculative, and it does not fully account for the sheer scale of the construction. You do not need 60,000 tons of stacked basalt to mark a boundary. A much smaller cairn would do the job. But the idea is not entirely without logic, and it might be that the structure served multiple purposes over a long period of time. Built for one reason, used for another, remembered for a third. The fifth hypothesis is perhaps the most open-ended, that the structure was a foundation, a base for something built on top of it that no longer exists. Wood rots, mud brick dissolves, thatch disappears. If the cone of basalt was originally the foundation platform for a large wooden or mud brick structure, a temple, a communal building, a tower, then the absence of any obvious function in the stone itself would make sense. The stone was never the finished product. It was the base. The problem with this idea is that 12 meters of stacked stone is an unusual foundation for a building. Most ancient foundations are flat or at least level. A cone is not an intuitive shape for a building platform, but it is not impossible that the upper portion of the cone was leveled or modified in a way that is not apparent from sonar data alone. Without a proper excavation, it is genuinely hard to say what the top of the structure looks like in detail. What is striking when you lay these hypotheses out side by side is that each one has something going for it and something working against it. The cairn theory fits the regional tradition, but lacks burial evidence. The fish trap theory fits the location, but not the design. The ceremonial platform theory fits the cultural context, but cannot be tested easily. The navigational marker theory fits the lake setting, but not the scale. The foundation theory is structurally plausible, but architecturally unusual. None of them is obviously wrong. None of them is obviously right. The structure sits there, at the bottom of the lake, not quite matching any single explanation cleanly. This is actually not unusual for large prehistoric monuments. Stonehenge has been interpreted as a burial ground, a solar calendar, a healing site, a political gathering place, and a territorial marker at various points in the scholarly literature, and the current consensus is that it was probably several of these things at different times. Rujamilhiri has been proposed as a calendar, a burial complex, a ritual site, and a territorial marker. Large stone constructions from the prehistoric world tend to resist single-function explanations, partly because they were built by communities whose symbolic and practical lives were not neatly separated the way we might imagine, and partly because they were used over long periods of time during which their function may have changed. It is also worth sitting with the possibility that the purpose of the Galilee structure was something we simply do not have a good conceptual category for. The people who built it lived in a world that was meaningfully different from anything we have direct access to. Their social structures, their belief systems, their relationship to the landscape and the water and the seasons, these are things we can partially reconstruct from archaeology, but only partially. It is possible that the structure served a function that made complete sense within its original cultural context, and that we would recognise immediately if we could see it in use, but that does not map cleanly onto any of the categories we bring to it from our own framework. That is a humbling thought, not a mystical one, just a realistic acknowledgement that our interpretive tools have limits. What all of the hypotheses share, regardless of their specific claims, is an assumption that the structure was built intentionally and for a reason. That part is not in dispute. The arrangement of the stones, the consistent cone shape, the scale of the undertaking, these are not things that happen by accident or by natural process. Someone decided to build this. Someone organised the labour, sourced the stone, directed the work, and saw it through to completion. The why behind that decision is what remains open. But the decision itself was real, and it was made by real people who had a reason that mattered to them. There is something quietly striking about that. The structure has been sitting at the bottom of the Sea of Galilee, for somewhere between 2,000 and 12,000 years, and in all that time, whatever reason it was built for has been lost. The people who knew the answer are gone. The tradition that gave the structure its meaning, if there was a living tradition connected to it, has been broken for so long that no memory of it survives in any text or oral account that has been identified. The lake has kept the secret, not out of any dramatic mysteriousness, but simply because water and time do what they do. What we are left with is the structure itself and the questions it generates. And the next question that follows naturally from purpose is the question of how. Because even if we cannot say what the structure was for, we can try to understand what it would have taken to build it. 60,000 tons of basalt does not move itself. The stones did not stack themselves into a cone. Someone brought them there, and someone arranged them, and that process, the logistics of it, the human effort behind it, is a question that the archaeology of the region can at least begin to address, even if it cannot fully answer it. So let us think about the stone itself for a moment. Not the shape, not the purpose, not the dating, just the raw physical reality of what it would mean to gather 60,000 tons of basalt and stack it into a cone 12 metres high and roughly 230 metres across. That is not a project you begin on a Tuesday morning with a few spare hands. That is something that requires planning, coordination, sustained effort over a significant period of time, and a social structure capable of organising all of that without it falling apart halfway through. Basalt is heavy. It is one of the denser common rock types, typically somewhere around 3 grams per cubic centimetre, which means that even a moderately sized basalt boulder, something you could just barely wrap your arms around, might weigh several hundred kilograms. The stones in the Galilee structure are not uniformly sized, and without a detailed excavation, it is difficult to know the full range of their dimensions. But sonar imaging and the dives that have been conducted suggest a rough, irregular stacking of stones that are substantial in size. Not the kind of thing one person lifts alone, or even 2 or 3. Many of them would have required groups of people working together with ropes, levers, or some kind of sledge or roller system to move at all. The nearest likely source of basalt is the eastern shore of the lake and the Golan Plateau, which rises steeply to the east and northeast. The Golan is volcanic terrain, and basalt outcrops there are abundant and accessible. Some researchers have suggested that the stones may have been gathered from the lakeshore itself, or from riverbeds feeding into the southern basin, where basalt cobbles and boulders accumulate naturally through erosion and transport. This would have reduced the distance somewhat, though it would not have made the work easy. Moving stone from even a relatively close source to a construction site, and then lifting it into place is physically demanding work under any circumstances. What is notable, and somewhat puzzling, is that no evidence of quarrying has been found at any obvious source site near the structure. No tool marks on exposed basalt faces, no piles of waste stone, no clear signs that a particular outcrop was systematically worked to produce building material. This absence is not conclusive. The area has not been exhaustively surveyed for quarrying evidence, and any such evidence might have been obscured by subsequent activity or natural erosion over thousands of years. But it does mean that the supply chain for the structure remains at the moment essentially undocumented. We know the stone had to come from somewhere. We just do not know exactly where or how it was transported to the site. The transportation question is its own puzzle. If the structure was built on dry land, which most researchers believe is likely given the lake-level history, then the stones would have needed to be moved overland to the construction site and then arranged there. The southern basin of the Sea of Galilee is relatively flat and low-lying, which would have made ground transport somewhat easier than it would have been across rougher terrain. Wooden rollers, sledges, and large teams of people pulling together are the standard explanations for how prehistoric communities moved heavy stone, and there is no particular reason to think the builders of the Galilee structure used anything fundamentally different. These methods work. They're slow, and they require a lot of people, but they work. Stonehenge was built using variations of these techniques. The megalithic tombs of Ireland were built using these techniques. The dolmens of the Golan Heights, which are made of similar basalt and are scattered across the plateau in considerable numbers, were built using these techniques. What the labour estimate actually looks like depends on a number of assumptions. How many workers were available, how far the stone had to travel, how many hours per day the work continued, how long the construction took in total. Archaeologists who study megalithic construction have developed rough models for estimating labour inputs, and while these models vary in their assumptions, the general picture for a structure of this size is consistent. You're looking at a very large workforce sustained over a substantial period of time. Some researchers working from analogous sites have estimated that a construction project involving tens of thousands of tons of stone would require hundreds to potentially thousands of workers, sustained over years or possibly decades. That is not a precise figure for the Galilee structure specifically. There has not been a formal published labour analysis for this site in the way that has been done for, say, the pyramids or Stonehenge, but it gives a sense of the scale of human organisation that would have been involved. And that scale of organisation is, in some ways, the most interesting part of this question, because the kind of society that can mobilise hundreds or thousands of people to move 60,000 tons of stone is not a small, loosely organised band of foragers living hand to mouth. It is a community with surplus food, surplus time, surplus labour, and with some form of authority or social structure capable of directing that surplus toward a collective project. Whether that authority was religious, political, hereditary, or some combination of these things is impossible to say from the archaeological record alone. But the capacity for large-scale collective action has to have been there. The structure is proof of it. This is actually one of the more significant things about the discovery, even though it is easy to overlook when you are focused on the mystery of the shape or the purpose. The structure tells us something about the society that built it, regardless of what it was built for. It tells us that the people of the southern Sea of Galilee region, at whatever point in the past this was constructed, were capable of organising labour on a scale that most people would not associate with the prehistoric Levant. We tend to think of the ancient Near East as a region where large-scale organised construction began with the Sumerians, with the emergence of cities and writing and formal state structures around 5,000 years ago. But the evidence from sites like Göbekli Tepe in southeastern Turkey, which was built around 11,000 years ago by communities that had not yet adopted farming, has been pushing that assumption back considerably. Göbekli Tepe required enormous coordinated labour. It predates agriculture. It suggests that the capacity for large-scale collective construction is older and more widespread than the conventional narrative assumed. The Galilee structure may be pointing in a similar direction, depending on when it was built. If the construction dates to the Neolithic or early Chalcolithic, which some researchers consider plausible, then it would represent a significant example of organised monumental construction in the southern Levant from a period when we have relatively little evidence of that kind of capacity in this specific region. The Jordan Valley and the Galilee area were inhabited during these periods. There are known Neolithic and Chalcolithic sites in the region, places like the site of Shah Hagolan on the Yarmouk River, which dates to around 7,000 years ago and shows evidence of a substantial settled community, or the Chalcolithic sites of the northern Negev and Jordan Valley. These communities were farmers and herders, not nomads. They had villages, they had pottery, they had the beginnings of social complexity. Whether they had the organisational capacity to build something like the Galilee structure is a question that the structure itself is now forcing researchers to take seriously. If the structure is younger, closer to the early Bronze Age, around 3000 to 4000 BCE, then the social context shifts somewhat. The early Bronze Age in the Levant is a period of increasing urbanisation, trade networks, and political complexity. Communities in this period were building walled towns, maintaining long-distance trade connections, and developing the early forms of the social hierarchies that would eventually produce the city-states of the ancient Near East. A large stone construction project in this context would be ambitious, but not entirely surprising. There are other examples of significant construction from this period in the region. Rujum el-Hiri, which dates to roughly this era, being the most obvious nearby comparison. The connection to Rujum el-Hiri is worth dwelling on for a moment, because it raises a question about the broader cultural landscape of the region during the likely construction period. Rujum el-Hiri, sometimes called Gilgal Rephaim in Hebrew, meaning the Wheel of the Giants, is a large concentric stone circle located on the Golan Plateau, about 16 kilometers northeast of the Sea of Galilee. It was built of basalt. It is enormous. The outer ring is roughly 160 meters in diameter, and the total weight of stone involved is estimated at around 40,000 tons. It dates to somewhere between 3,000 and 5,000 BCE, depending on the researcher and the dating method used. Its purpose is debated. Solar calendar, burial complex, ritual site, territorial marker, the same range of hypotheses that surrounds the Galilee structure, which is perhaps not a coincidence. The point is that whoever was living in this region during the Bronze Age and possibly earlier was building large things out of basalt. This was not a single anomalous event, it was a pattern. The Golan Plateau is dotted with dolmens, thousands of them, spread across the landscape, many of them also made of basalt, many of them also poorly dated and poorly understood. The Galilee structure is the largest and the most dramatic of these constructions, and the only one that ended up underwater, which is part of why it remained unnoticed for so long. But it is not a complete outlier in terms of the cultural tradition it appears to belong to. What is missing, though, is a clear picture of the specific community that built it. The builders of Rujum el-Hiri are not individually known to us, but we have a general sense of the cultural context, the Chalcolithic and early Bronze Age populations of the Golan and the Jordan Valley. For the Galilee structure, we do not even have that level of specificity because we do not know when it was built. The potential builders span a range from Neolithic farming communities to early Bronze Age proto-urban societies, and those are meaningfully different kinds of people with meaningfully different capacities and social structures. Until the dating question is resolved more precisely, the question of who built it remains almost as open as the question of why. There is also a quieter puzzle embedded in all of this, which is the question of what happened to the builders afterward. Large construction projects leave traces. They leave quarrying sites, tool deposits, settlement remains near the construction area, middens, hearths, pottery. At Rujum el-Hiri, there is a burial cairn at the centre that has provided some archaeological material. At Stonehenge, the surrounding landscape is dense with associated monuments, burial mounds and settlement evidence. At the Galilee structure, the underwater environment has complicated the detection of any associated remains, and the surveys conducted so far have focused primarily on the structure itself rather than on the broader surrounding lakebed. It is entirely possible that there are associated remains, settlement debris, tool deposits, organic material, somewhere in the sediment around the base of the structure, waiting to be found. But they have not been systematically looked for yet, at least not in any published account. This is one of the frustrating realities of the current state of research. The structure was identified, its basic dimensions were measured, a paper was published, and then, for a variety of reasons that we will come to, the investigation has not progressed as far as the initial discovery might have suggested it would. The builders remain, for now, essentially anonymous. We know they existed, we know they were capable of extraordinary things, we know they lived somewhere near the southern shore of a lake that has been continuously inhabited for thousands of years since their time, and we know almost nothing else about them specifically. What the structure does, in the absence of those specifics, is raise the floor of what we know was possible in this region and in this general period. 60,000 tons of stone, deliberately arranged in a place that was presumably meaningful to the people who chose it. That is a fact about the human past in the Levant that was simply not known before 2003. It changes, in a small but real way, what we can say about the capabilities and the ambitions of the people who lived here before written history began That is not nothing. In fact, for a field where new facts about the deep past are genuinely rare, it is quite a lot. But capability and ambition require something else to be sustained over the course of a major construction project: time. Specifically, time during which the site was accessible, the labour was available, and the conditions were right for building. And that brings us back to the lake itself, because the Sea of Galilee has not always looked the way it looks today, and understanding when the structure went underwater is one of the keys to understanding when and under what conditions it was built. The Sea of Galilee is not a static thing. It never has been. People tend to think of lakes as fixed features of the landscape, permanent and reliable, the way a mountain or a coastline feels permanent. But lakes breathe. They rise and fall with rainfall, with snowmelt from the mountains that feed their source rivers, with evaporation rates that shift across seasons and across centuries. The Sea of Galilee is fed primarily by the Jordan River in the north, and it loses water through the Jordan River outlet in the south, as well as through evaporation from its surface, which given the heat of the region is considerable. In a good year, with heavy winter rains and snowpack on Mount Hermon, the lake fills. In a dry year it drops. And over geological and historical timescales, those fluctuations have been dramatic enough to completely change the character of the lake's southern basin, which is the shallower, flatter part of the lake where the structure sits. The current lake level is measured relative to sea level, and because the Sea of Galilee sits in the Jordan Rift Valley, its surface is actually well below the level of the Mediterranean, roughly 210 metres below sea level under normal conditions. The Israeli Water Authority has established what it calls the upper and lower red lines for the lake. The upper red line is approximately 208.5 metres below sea level, beyond which the lake risks flooding the surrounding infrastructure, and the lower red line is approximately 213 metres below sea level, below which water intake becomes difficult and the lake's ecological health begins to suffer. Between those two lines is the operational range within which the lake is supposed to be managed. In practice, the lake has crossed both lines at various points in recent decades, sometimes due to drought, sometimes due to excess rainfall. But those modern management lines are really just a thin slice of the lake's actual range of variation. Over thousands of years, the water level has swung far more dramatically. Paleoclimate studies of the region, using sediment cores, pollen records, and isotopic analysis of materials from the lake floor and the surrounding area, have shown that the Sea of Galilee has been significantly lower than its current level during various periods of the Holocene. During some dry intervals, particularly in the early to middle Holocene, the lake may have been 10 or even 15 metres lower than it is today. At those levels, the southern basin, which averages somewhere between 9 and 16 metres deep in the area where the structure sits, would have been substantially shallower, or in some areas, dry land. This is the key point. If the lake was low enough during the period when the structure was built, then the builders were not working in water at all. They were working on land, or at most, they were working at the edge of the lake in the shallows, where the southern basin floor was exposed or barely submerged. The structure would have been a terrestrial construction, a stone monument built on the ground, that later became submerged as the lake level rose again. This is the most plausible explanation for how it was built, because constructing a 60,000-ton stone monument underwater using the tools available in the Bronze Age or Neolithic period is essentially impossible. You build it on land, and then the water comes up around it. The monument does not move. The lake does. This kind of submergence is not unusual in the archaeological record, globally speaking. There are submerged Neolithic villages off the coast of Scotland, submerged Bronze Age settlements in the Aegean, submerged structures along the coastlines of India, Japan, and the Gulf of Mexico. Whenever sea levels or lake levels rise, whatever was built near the water's edge goes under. The Sea of Galilee has its own version of this phenomenon. There are other submerged features in the lake. We will come to those in a moment, and all of them point to the same basic conclusion. The lake was lower, people built things near or on the exposed floor, and then the water returned. For the stone structure specifically, the question of when it's submerged is directly connected to the question of when it was built. If researchers could establish a clear timeline for the lake's water level history with enough precision, they could potentially bracket the construction period more tightly. If the structure was built on dry land, then it must have been built during a period when the southern basin floor was exposed, which means during a period of low lake level. If they can identify when those low water periods occurred and cross-reference that with the sediment layers around the base of the structure, they might be able to narrow the date range considerably. The difficulty is that the lake's water level history is known in broad strokes but not in fine detail. The paleoclimate record for the region is good enough to identify general trends: wetter periods, drier periods, centuries of low lake levels, but not always precise enough to say exactly when and by exactly how much the lake was lower at any given moment. There is ongoing research into this question, and sediment cores from the lake floor have provided useful data, but the resolution of that data is not always fine enough to answer the specific question of when the southern basin was last dry or very shallow. What researchers do have is a general sense that the Holocene period, the roughly 12,000 years since the end of the last ice age, included several significant dry intervals in the Levant. The early Holocene, from about 10,000 to 7,000 years ago, was in many places wetter than today, but there were also dry episodes. The mid-Holocene, from roughly 6,000 to 4,000 years ago, included a prolonged dry period in parts of the Middle East that is well documented in the climate record. The early Bronze Age, which is one of the favoured construction periods for the structure, falls within or near the end of this mid-Holocene dry interval in some reconstructions. If the lake was significantly lower during the early Bronze Age, say 10 or more metres below its current level, then the southern basin floor where the structure sits could have been accessible, or at least very shallow. This remains a working hypothesis rather than a confirmed conclusion. The sediment around the base of the structure has not been cored and analysed in a way that has been published in detail, as far as the available literature shows. The connection between the lake level history and the construction date is logical and well reasoned, but it has not been firmly established through direct physical evidence at the site. It is the kind of inference that makes sense and that researchers point to, but that has not yet been confirmed by the kind of careful, targeted fieldwork that would settle the question. Then there is 2018. In the summer of 2018, the Sea of Galilee dropped to near-record low levels following several consecutive dry winters. The lake fell to around 214 metres below sea level, below the lower red line, and close to the lowest levels recorded in the modern era. The drop was severe enough that the Israeli government launched an emergency desalination program to supplement the lake's inflow, and there was genuine concern about the lake's long-term health. But for archaeologists, the low water level had a different significance. It exposed more of the southern basin floor than had been visible in decades. Aerial photographs taken during this period showed large stretches of the lakebed emerging from the water, and the upper portions of the stone structure became more visible than they normally are. The 2018 drought prompted renewed media attention to the structure, with photographs and videos circulating online, and a new wave of public interest in what exactly was sitting on the bottom of the Sea of Galilee. For researchers, it was also a reminder that the structure's visibility changes with the lake level, that in drier periods, a person standing on the exposed southern basin floor might have been able to see the upper stones of the structure rising above the waterline, or might have been able to walk right up to it. This raises an interesting question about why the structure was not documented earlier. If low water periods in the modern era have made it partially visible, then presumably similar low water periods in historical times would have done the same. The structure may have been seen, or at least noticed, by fishermen or local inhabitants at various points over the centuries. Whether it was recognised as significant or simply noted as a strange pile of rocks in the shallows is impossible to know. There are accounts, in some of the literature surrounding the discovery, that local fishermen were aware of a rocky area in the southern basin that was a hazard to nets and boats. Whether this refers to the structure specifically is not entirely clear, but it is at least consistent with the idea that the structure's existence was not entirely unknown to people who worked on the lake. What was missing was not awareness that something was there, but the scientific framework to recognise it as a constructed monument and the tools to properly document and study it. That framework arrived in 2003 in the form of sonar survey equipment and a team from the University of Haifa looking at the lake bottom in a systematic way. The lake level question also matters for a more practical reason, which is that it affects how the structure has been preserved. Stone does not decay in water the way organic material does, and in some respects the submergence of the structure may have protected it from the kind of disturbance that a surface monument would have experienced over the same period. There has been no quarrying of the stones for building material, no casual removal of rocks by farmers clearing fields, no gradual dismantling by people who needed construction material for other purposes. The lake has, in a sense, kept the structure intact. The trade-off is that the submergence has also prevented the kind of surface survey and excavation that would normally be the first step in studying a monument like this. The sediment that has accumulated around the base of the structure over however many centuries or millennia it has been. Underwater is both a problem and a potential resource. It is a problem because it obscures the base of the structure and makes it difficult to understand the relationship between the structure and the original ground surface. It is a resource because sediment layers can be dated, if the right organic material is present, and can preserve pollen, seeds, and other biological material that tells you something about the environment at the time of deposition. If a layer of sediment directly against the base of the structure could be dated to a specific period, that would give a minimum age for the structure. It must have been built before that sediment was deposited. This kind of stratigraphic dating is standard practice in terrestrial archaeology, but it is considerably more difficult to execute underwater, where the sediment is easily disturbed by currents, by the movement of the lake, and by the physical act of diving and sampling. None of this has been done in a systematic, published way as of the time the main papers on the structure were written. The structure has been sonar mapped, photographed, and described. Its dimensions are known. Its general character, the basalt stones, the conical shape, the lack of mortar, has been documented. But the detailed sediment work that might pin down the timing of its submergence, and by extension help narrow the construction date, has not been completed or published. It is on the list of things that need to be done. It is not yet done. What the lake-level history tells us, even in its current incomplete form, is that the structure was almost certainly built on land or in very shallow water, that the lake subsequently rose and covered it, and that the timing of that submergence is one of the key variables in understanding when the structure was constructed. It also tells us that the lake is not a fixed backdrop to this story. It is an active participant. It rose and hid the structure. It dropped in 2018 and briefly revealed it again. It will continue to fluctuate, probably more dramatically in the coming decades as the climate of the region shifts. And each time it drops, the southern basin floor becomes a little more accessible, and the possibility of learning something new about what is sitting down there becomes a little more real. There is something quietly remarkable about the fact that the lake itself holds part of the answer to its own mystery. The water that obscures the structure also preserves it. The fluctuations that make it hard to study are the same fluctuations that eventually brought it within range of sonar equipment and diving surveys. And those same fluctuations, operating over thousands of years, shape the conditions under which the structure was built, used, and eventually forgotten beneath the surface of one of the most historically significant bodies of water in the world. The lake floor, it turns out, is not just a place where the structure sits. It is a place where other things have been found as well, things that suggest the southern basin of the Sea of Galilee has been a site of human activity for a very long time, and that the stone structure is not the only secret the water has been keeping. The last sentence is worth sitting with for a moment. The stone structure is not the only thing down there. The lake floor of the Sea of Galilee, and particularly the southern basin where the structure sits, has turned out to be something of an archaeological archive. A quiet, murky, difficult to access archive, but an archive nonetheless. And understanding what else has been found in and around these waters helps put the structure in a broader context, not as a single impossible anomaly floating in isolation, but as the largest and most puzzling piece of a much larger picture of human activity that has been accumulating on and around this lake for thousands of years. The most famous underwater find from the Sea of Galilee is probably the boat. In 1986, a severe drought dropped the lake level significantly, exposing mudflats along the northwestern shore near the village of Ginosar. Two brothers, Moshe and Yuval Lufan, who were amateur archaeologists from a nearby kibbutz, were walking the newly exposed shoreline when they noticed the outline of a hull emerging from the drying mud. What they had found was a wooden fishing boat, roughly 8.2 meters long and 2.3 meters wide, dating to somewhere between 100 BCE and 70 CE. It is now commonly referred to as the Jesus boat, not because there is any connection to the historical Jesus, but because it dates to roughly the same period and represents the kind of vessel that would have been common on the lake during the 1st century. The boat was preserved in remarkable condition by the anaerobic mud, meaning mud with very little oxygen, which prevents the microbial decay that would normally destroy wood over that kind of time span. Its excavation was an extraordinary undertaking, involving the careful injection of polyurethane foam to stabilize the waterlogged wood before it could be moved, and it is now on display at the Yigal Allon Museum at Kibbutz Ginosar, where it has been a significant draw ever since. The point here is not the boat's religious associations, but what its discovery illustrates. The lake floor preserves things. The same conditions that kept that wooden boat intact for 2,000 years are working on everything else down there as well. Anchors have been found in the lake in considerable numbers, stone anchors mostly of the kind used by ancient fishing boats, roughly shaped blocks of basalt with a hole drilled through the top for a rope, simple and functional and very durable. Dozens of them have been documented in the shallower areas of the lake, particularly along the northern and western shores where ancient fishing settlements were concentrated. Some date to the Bronze Age, some to the Iron Age, some to the Roman period. Together they form a kind of record of the fishing industry on the lake across several thousand years. The basalt they are made from is the same basalt that makes up the stone structure in the southern basin, which is perhaps not surprising given that basalt is simply what the region produces in abundance. But it is a reminder that the material world of the people who lived around this lake was built from the same volcanic rock in many different forms and for many different purposes. There are also submerged remains of structures along certain parts of the shoreline. Not dramatic ruins, not columns or walls that you would photograph for a travel magazine, but the kind of low, worn, sediment-covered remnants that require careful survey work to identify and interpret. Some of these are associated with known ancient settlements whose shorelines have shifted as the lake level changed over the centuries. The town of Magdala, on the northwestern shore, which is mentioned in historical sources and has been the subject of ongoing archaeological excavation on land, has associated underwater remains that have been surveyed. Capernaum further north similarly has areas where ancient activity extended to the waterline and possibly beyond it. The lake level in antiquity was not always what it is today, and settlements that were built near the shore in one period may have found themselves partially inundated in another, or alternatively sitting further from the water than they expected as the lake contracted during dry periods. Pottery is perhaps the most common find. Sherds of ceramic vessels turn up across the lake floor in surveys, some of them in concentrations that suggest specific activity areas, places where boats were loaded or unloaded, where fish were processed, where people gathered near the water for various purposes. Dating pottery from the lake floor is not always straightforward because the pieces can be moved by currents and by the disturbance of the sediment, but in some cases the concentrations are coherent enough to suggest they are in or near their original depositional context. Bronze Age pottery has been found. Iron Age pottery has been found. Hellenistic and Roman period material is common. The lake has been in use, continuously and intensively for a very long time, and the material evidence of that use has been accumulating on the bottom in layers that are theoretically recoverable. All of this matters for understanding the stone structure because it establishes that the southern basin, and the lake more broadly, is not an archaeological blank space. It is an environment that has been heavily used by humans across many periods, and that use has left physical traces. The stone structure is the largest and most dramatic of those traces, but it exists within a landscape of human activity, not apart from it. This is actually one of the reasons researchers are cautiously optimistic that future work in the lake could produce meaningful results. There is clearly material there. The question is how to get at it. And that is where things become genuinely complicated, because conducting archaeology underwater in the Sea of Galilee is not simply a matter of putting on a wetsuit and diving down with a trowel. The lake is Israel's largest freshwater reservoir and one of its most important water sources. It feeds into the national water carrier, the infrastructure system that distributes water across much of the country. This means that the lake is managed by the Israel Water Authority, and any activity that could potentially affect water quality or the integrity of the lake ecosystem requires permits and oversight that go well beyond what a normal archaeological excavation would involve. Underwater excavation stirs up sediment. It introduces equipment, chemicals used for preservation or documentation, and human presence into the water column. These are not trivial concerns in a reservoir that supplies drinking water to millions of people. The regulatory environment around the lake is, as a result, considerably more restrictive than it would be for a site on dry land, and this has been a persistent constraint on what researchers have been able to do. There is also the visibility issue, which is worth describing in some detail because it is easy to underestimate. The Sea of Galilee is not a clear tropical sea. It is a freshwater lake in a semi-arid region, and it receives significant input of sediment from the Jordan River and from runoff during rain events. The water carries suspended particles that scatter light and reduce visibility, sometimes quite dramatically. On a good day, underwater visibility in the lake might be 3 to 5 meters. On a bad day, after rain, or during periods of high biological activity, it can drop to less than a meter. This makes underwater photography difficult, makes systematic visual survey of the lake floor slow and painstaking, and makes it very hard to get a clear visual impression of a large structure from close range. You can be right next to one of the basalt stones of the structure and not be able to see more than a small portion of it at one time. This is part of why the sonar data was so important. Sonar does not depend on optical visibility, and it was the sonar image that first made the full scale of the structure legible. But sonar gives you shape and dimension, not texture and detail. For the finer grained information, the character of individual stones, the nature of any mortar or packing material, the presence of tool marks or other work surfaces, you need eyes and cameras close to the stone, and that is where the visibility problem bites. Sediment disturbance is another real concern. The lake floor in the southern basin has a layer of fine sediment over much of its surface, and that sediment is not firmly consolidated. Divers moving through the water, even carefully, create currents that lift sediment and reduce visibility further. A diver examining one part of the structure can inadvertently cloud the water for another diver working nearby. This is manageable with careful technique and small team sizes, but it means that survey work proceeds slowly, and that any attempt to actually excavate, to remove sediment from around or beneath stones to understand the structure's base or interior, would require very careful planning to avoid destroying the stratigraphic context that the sediment preserves. The combination of these factors, the water authority regulations, the visibility, the sediment sensitivity, the cost of sustained underwater operations, means that the stone structure has been surveyed and documented but not excavated. The stones have been photographed. The overall shape has been mapped with sonar. Divers have examined the surface of the structure and confirmed its character. But nobody has dug into it. Nobody has systematically removed sediment from around the base to look for datable material or for artifacts that might have been deposited there during the structure's period of use. Nobody has examined the interior of the cone to see what, if anything, is inside. The structure's secrets, to the extent that it has them, are still sealed by water and sediment and the practical difficulties of the environment. This is not a criticism of the researchers who have worked on it. The constraints are real, and working within them requires creativity and patience. The use of multi-beam sonar, which produces detailed three-dimensional maps of the lake floor, has been genuinely productive. Underwater photography, even in difficult visibility conditions, has added to the record. And the sediment coring that has been done in the vicinity, taking cylindrical samples of the lake floor sediment to study the layers, has contributed to understanding the environmental history of the southern basin, even if it has not yet produced the direct dating evidence that researchers are looking for. These are the tools available, and they have been used thoughtfully. What is perhaps most striking when you step back from the practical details is the contrast between the scale of the structure and the scale of the investigation. 60,000 tons of basalt sitting on the floor of one of the most historically studied bodies of water in the world, and the primary published scientific account of it is a paper from 2013 that runs to a handful of pages. Not because the researchers are not interested or not capable, but because the environment makes sustained, systematic investigation genuinely hard, and because the resources required for underwater archaeology are substantial and not always available. It costs money to run dive operations. It costs money to process multi-beam sonar data. It costs money to do the sediment analysis that might finally produce a date. And the structure, for all its size, does not come with an obvious funding narrative the way some archaeological sites do. It is not connected to a famous historical event. It does not have a name. It sits in a lake that is already famous for other reasons, and it has to compete for attention and resources with everything else that is happening in a region that is extraordinarily rich in archaeological material. There is something almost poignant about that. A structure that took an enormous amount of human effort to build, that has survived for what may be thousands of years, and that represents one of the largest prehistoric constructions in the region, sitting quietly in the dark at the bottom of a lake, largely unstudied, waiting for the resources and the conditions that would allow a proper investigation. The other finds in the lake, the boat, the anchors, the pottery, at least have some degree of context, some connection to known historical periods and practices. The stone structure sits apart from all of that, older and stranger, and more difficult to place. It is surrounded by evidence of human activity across many centuries, but it does not quite fit into any of the categories that evidence represents. It is its own category, and understanding it will require its own dedicated effort. That effort, when it comes, and most researchers who are aware of the structure seem to believe it will come eventually, will likely draw on methods that are still being developed. Underwater excavation technology has improved significantly in recent decades. Remote-operated vehicles with high-resolution cameras and manipulator arms can do work that previously required human divers. Advances in sediment coring and analysis have made it possible to extract more information from smaller samples. Ground-penetrating sonar, adapted for underwater use, might eventually be able to image the interior of the structure without physical excavation. None of these methods is a magic solution, but together they represent a toolkit that is more capable than what was available when the structure was first described in 2013, and the researchers who would use those tools are paying attention. The structure has not been forgotten. It is on the list. It is in fact near the top of the list for anyone working on the underwater archaeology of the Sea of Galilee. What that investigation might eventually reveal about the structure's age, its purpose, its builders, and its relationship to the other evidence of human activity in and around the lake is genuinely hard to predict. But the fact that the lake floor around the structure is itself an archaeological layer cake full of material from many different periods, means that any future excavation will be operating in a rich context. The structure did not sit in an empty landscape when it was built. It sat in a place where people lived and worked and moved around. Some of that context preserved in the sediment of the southern basin is still there, and understanding the structure will almost certainly require understanding that context as well, the broader archaeology of the lake, the settlement patterns of the surrounding region, and the long history of human activity that has been quietly accumulating in the water above and around 60,000 tons of carefully stacked basalt stone. That broader picture, this scientific effort to piece it together and what it might mean for our understanding of the people who built the structure, is where the story turns next. So let us talk about the scientific community more directly, and about what it actually looks like when researchers try to study something like this. Because there is a version of this story that makes it sound simple. A structure was found, scientists are investigating it, answers will eventually come. But the reality is considerably more complicated, and understanding that complexity is part of understanding why this structure remains, more than 20 years after its discovery, one of the least documented major archaeological finds in the region. The University of Haifa has been the institutional home of most of the serious work done on the structure. Danny Nadel, who was part of the original discovery team alongside Yitzhak Paz, has remained one of the researchers most closely associated with it. His background is in prehistoric archaeology, which is appropriate given the likely age range of the structure, and his work in the region extends well beyond the lake itself. He is someone who has spent decades thinking about the people who lived in and around the Jordan Valley, and the Galilee Basin in the deep past, and the stone structure fits into that broader research interest in a natural way. But one person, or even a small team, working on a site this large and this difficult to access, can only do so much within any given period of time or budget cycle. The primary published account of the structure, the 2013 paper in the International Journal of Nautical Archaeology, was a significant moment. It brought the structure to the attention of a much wider audience. Not just regional archaeologists who might have heard about it through conference presentations or informal channels, but researchers working in underwater archaeology, in prehistoric studies, in the archaeology of the Levant more broadly. The paper described the structure's physical dimensions, its location, its composition, and the methods used to document it. It laid out the main interpretive possibilities, the cairn hypothesis, the fish trap hypothesis, the ritual platform idea, and was honest about the limits of what could be said with confidence. It was, by the standards of academic publication, a careful and responsible piece of work. What it was not, and could not be, was a complete investigation. A paper describing a newly recognised site is a beginning, not a conclusion. It is an announcement that something is there and that it deserves sustained attention. The expectation, in a normal archaeological context, would be that such a paper would be followed by further fieldwork, further publication, a growing body of evidence that gradually narrows the uncertainty. That follow-up has been slower than many researchers would have hoped. There have been subsequent presentations, ongoing discussions and continued sonar work, but the volume of published material specifically focused on the structure remains thin relative to its size and significance. This is not a complaint about the researchers involved. It is a reflection of how underwater archaeology works and of the particular constraints that apply to this site. Multi-beam sonar is the tool that has done the most work here, and it is worth explaining what it actually does. Unlike the single-beam sonar used in the original 2003 survey, which sends a single pulse downward and measures the return, multi-beam sonar sends out a fan of pulses across a wide swath of the seafloor simultaneously. The returns from all of those pulses are processed together to create a detailed three-dimensional map of the bottom. The resolution can be quite good enough to see individual large stones and the general shape of a structure. It is how researchers have been able to describe the cone's dimensions with confidence. The roughly 230-metre diameter, the 12-metre height, without having to physically measure every part of it. The sonar data gives you a picture that is, in many ways, more complete than what a diver could see on a single dive in murky water. But sonar has limits. It tells you about surface shape. It does not tell you what is inside the structure, how the stones are arranged below the surface layer, whether there are voids or chambers or burial deposits within the cone. For that, you need physical access. You need divers or remote-operated vehicles working slowly and carefully through the structure itself. And that is where the practical difficulties become acute. Diving in the Sea of Galilee is not straightforward. The lake is Israel's primary freshwater reservoir, which means it is subject to strict water authority regulations. Any activity that might disturb the lakebed, and archaeological excavation by definition disturbs the lakebed, requires permits that involve multiple government bodies, including the Israel Water Authority, the Israel Antiquities Authority, and sometimes additional agencies depending on the nature and location of the work. These are not bureaucratic obstacles invented to frustrate archaeologists. They exist because the lake is genuinely sensitive. It supplies drinking water to a significant portion of the country's population. Disturbance of the sediment affects water quality. Introduction of equipment can affect the ecosystem. These are real concerns, and the permitting process reflects them. The result is that underwater excavation in the lake requires a level of planning, coordination, and institutional support that goes well beyond what a university research team can typically assemble on its own. It requires partnerships with water authority bodies, environmental assessments, carefully designed excavation protocols that minimize sediment disturbance, and the logistical infrastructure to conduct sustained dive operations in a body of water that is not set up for that kind of work. The lake does not have a permanent archaeological dive operation. Every field season requires rebuilding that infrastructure from scratch, more or less. Visibility is another issue that comes up repeatedly in discussions of the site. The Sea of Galilee is not a clear tropical sea. The water carries suspended particles, sediment, algae, organic material, that limit how far a diver can see. In the southern basin, where the structure sits, visibility can be as low as a few meters on a bad day, and rarely exceeds 10 or 15 meters even under good conditions. This means that a diver working on the structure is always working in a limited field of view. You can see the stones immediately around you. You cannot see the overall shape of what you are working on. You are, in a sense, always working blind in the larger sense, relying on the sonar maps to tell you where you are within the structure and what the surrounding topography looks like. This is manageable, but it slows everything down and makes systematic documentation harder. Underwater photography has been used to build a visual record of the structure's surface, and the images that exist are striking in their way. Dark basalt stones, worn smooth in places, covered in a thin layer of algae and sediment, sitting in the dim greenish light of the lake bottom. They give you a sense of the texture and scale that sonar maps cannot. But photography in these conditions requires careful management of lighting and camera positioning, and building a comprehensive photographic record of a structure 230 meters across is a substantial undertaking even under ideal conditions. Sediment coring has been the other main tool in use. Cores taken from the lakebed sediment around the structure have helped researchers understand the environmental history of the southern basin, how the lake level has changed over time, what the climate was like during different periods, what kinds of organic material have accumulated in the sediment at different depths. This is valuable context. It helps build the framework within which the structure's construction date might eventually be placed. But sediment cores taken from around the structure are not the same as material taken from within it, or from its immediate base. The cores give you the environmental background. They do not give you the construction date. What a proper investigation of this structure would require, if you were designing it from scratch with adequate resources, is something considerably more ambitious than what has been done so far. It would start with a comprehensive high-resolution multi-beam sonar survey of the entire structure and its immediate surroundings, more detailed than what exists, capable of resolving individual stones across the whole surface. It would include systematic underwater photography and video documentation, using remotely operated vehicles, which can cover more ground than human divers and can operate in conditions that would be unsafe or impractical for people. It would involve carefully targeted excavation at specific points, the base of the structure, where sediment accumulation might preserve organic material from the construction period, and potentially within the interior if access is possible without destabilizing the stones. And it would require the kind of sustained, multi-season fieldwork that allows you to actually process and analyze what you find, rather than collecting samples and then waiting years for the resources to study them. None of this is impossible. It is expensive, and it requires institutional commitment over a period of years rather than months. But it is the kind of work that has been done at other complex underwater sites around the world. The remains of submerged Bronze Age settlements in the Aegean, the underwater caves of the Yucatan with their Pleistocene-era human remains, the submerged landscapes of the North Sea where Mesolithic sites have been found. These are all places where underwater archaeology has made significant progress in recent decades, using methods that are increasingly sophisticated and increasingly productive. The Sea of Galilee structure is, in terms of its physical scale and its potential historical significance, at least as deserving of that kind of effort as any of those sites. And the researchers who are aware of it seem to genuinely believe that the effort will come. Danny Nadell and others who have worked on the structure have spoken about it in terms that suggest ongoing interest and ongoing plans, even when the pace of published output has been slow. The structure is not forgotten. It is, if anything, a source of quiet frustration for the people who know about it most closely, a site that clearly deserves more than it has received, waiting for the combination of funding, institutional support and favourable conditions that would allow a serious investigation to begin. There is also the question of what the investigation would need to include beyond the physical structure itself. The lake floor around the cone is not empty. There are other archaeological features in the southern basin, and understanding the structure in isolation, without understanding its relationship to the surrounding landscape, both above and below the water, would give an incomplete picture. A full investigation would ideally include systematic survey of the surrounding lakebed, looking for associated features, possible causeways or pathways leading to the structure, other stone arrangements that might indicate the presence of a larger site, evidence of activity on the lakeshore during the construction period. This kind of landscape archaeology, applied to an underwater context, is more demanding than simply excavating a single site, but it is the approach that tends to produce the most meaningful results. The interest from outside Israel has also been real, if not always easy to translate into action. Researchers working on megalithic traditions in other parts of the world have taken note of the structure. Its potential relationship to other large stone constructions in the region, Rujum el Hiri, the Golan Dolmens, the various cairn fields of the Levant, makes it relevant to a broader set of questions about prehistoric social organisation and monumental construction that are being actively studied by archaeologists across the Middle East and beyond. But international collaboration on a site like this requires navigating not just the scientific questions, but the administrative and political frameworks that govern access to the lake, and those frameworks are not always easy for outside researchers to engage with. What the scientific community has at this point is a detailed sonar map, a body of underwater photographs, some sediment core data, and a set of carefully stated hypotheses about the structure's age and purpose. It has a published paper that describes the site and its significance. And it has a group of researchers who are genuinely committed to understanding the structure better, working within constraints that are real and not easily overcome. That is not nothing. It is in fact a reasonable foundation for the more intensive investigation that most people who know about the structure believe is eventually coming. But the gap between that foundation and a real answer, a confident date, a clear purpose, an understanding of who built it and why, remains large. The structure is, in the most literal sense, still mostly unknown. Its surface has been mapped, its shape has been described, its existence has been confirmed and published. But the questions that matter most, when, why, who are still open, and they will remain open until someone finds a way to get inside the cone, to sample the material at its base, to recover the kind of evidence that would allow a direct date to be established. That moment has not yet come, but the structure is patient. It has been sitting there for what may be thousands of years, and it is not going anywhere. And the fact that the scientific tools available for this kind of work are better now than they were in 2003, and better still than they will be in another decade, means that the odds of a real breakthrough are slowly improving. The question of what that breakthrough might mean, not just for understanding this one structure, but for what it tells us about the people who built it and the world they lived in, is where the story opens up into something considerably larger, and that is where things get genuinely interesting. Because the question of what this structure means, not just as an object, not just as an engineering puzzle, but as evidence of human life and human society at a particular moment in time, is the question that carries the most weight. It is the question that, depending on how the dating eventually resolves, could change the way we understand an entire chapter of human history in this part of the world. Start with what we know about the people who were living around the Sea of Galilee and the broader Jordan Valley during the periods when the structure was most likely built. If the construction dates to the early Bronze Age, somewhere around 3000 to 4500 BCE, then the builders were part of a world that was already, in some places, developing the early forms of what we would recognise as organised society. There were farming communities in the Jordan Valley by this point. There were settlements with architecture, with storage systems, with evidence of trade and craft production. The Chalcolithic period, which immediately precedes the early Bronze Age, running roughly from 4500 to 3500 BCE, left behind sites across the southern Levant that show communities capable of sustained collective effort. Copper smelting, irrigation agriculture, burial practices that involve significant labour and planning. These were not small, scattered bands of people living hand to mouth. They were communities with enough organisational capacity to plan and execute projects that required coordination across time and across groups. But 60,000 tonnes of basalt is a different order of magnitude than anything else we have from this region during those periods. That is the part that is hard to absorb. The dolmens of the Golan Heights, which are numerous and which represent a significant tradition of megalithic construction, are impressive, but they are individual structures, each involving perhaps a handful of large stones. Rujm el Hiri, the great stone circle about 16 kilometres from the lake, is the closest regional parallel in terms of scale, and it is itself not fully understood. But even Rujm el Hiri, with its concentric rings of basalt and its estimated 40,000 tonnes of stone, is somewhat smaller than the Galilee structure. If the cone beneath the lake was built by the same cultural tradition, or even by the same people, it represents the largest known single construction effort in the region's prehistoric record. That is a significant claim, and it is one that deserves to be taken seriously. Now push the date further back. If the structure turns out to be Neolithic, if it was built somewhere in the range of 6,000 to 10,000 years ago, then the implications shift considerably. The Neolithic in the Levant is a period we know reasonably well in some ways and poorly in others. We know that agriculture developed here early, that some of the world's oldest known farming communities existed in this region, that the transition from hunting and gathering to settled life happened gradually and unevenly across different areas. We know that Neolithic communities were capable of building permanent structures, of managing livestock, of producing pottery and groundstone tools. But we have tended to think of Neolithic society in this region as relatively decentralised. Villages and small communities, without the kind of hierarchical organisation that we associate with large-scale public works. Göbekli Tepe changed that assumption in a significant way. The site in southeastern Turkey, which dates to roughly 9,000 to 12,000 years ago, consists of massive carved stone pillars arranged in circular enclosures, built by people who were, as far as we can tell, still primarily hunter-gatherers, or in the very earliest stages of the agricultural transition. It was finished before pottery, before writing, before any of the things we typically associate with the kind of social complexity that builds large monuments. And yet there it is, a site that required the movement of stones weighing up to 20 tons, arranged with evident intentionality, decorated with carved reliefs of animals and abstract symbols. When Göbekli Tepe was first published to a wider audience in the early 2000s, it genuinely surprised a lot of people who study this period. Not because the evidence was unclear, but because it didn't fit the model. The model said that you needed settled agriculture, surplus production, and hierarchical leadership before you could build something like that. Göbekli Tepe said, not necessarily. The Galilee structure raises a similar kind of question, though from a different angle. It is not carved. It is not decorated as far as we know. It does not have the architectural elaboration of Göbekli Tepe's enclosures, but it is vastly heavier. 60,000 tons is not a number that resolves easily into the picture of a small Neolithic community gathering stones from the hillside on weekends. It implies something. It implies a workforce of significant size sustained over a significant period of time. It implies that someone, or some group of people, had the authority or the persuasive power to organise that workforce and keep it working toward a shared goal. It implies surplus. You cannot feed thousands of people doing non-subsistence labour unless someone somewhere is producing enough food to support them. And it implies a reason. People do not move 60,000 tons of volcanic rock without a reason that feels, to them, worth the effort. What that reason might have been is genuinely open. The cairn hypothesis, that this is a burial monument of some kind, is appealing partly because it fits a known pattern. Large cairns were built across the ancient world as markers for the dead, as places where the boundary between the living and the dead was acknowledged and maintained. In the British Isles, in Scandinavia, across the Caucasus, in parts of Central Asia, cairns of substantial size were constructed over individual burials or collective burial chambers. The tradition in the Levant is also documented, though typically on a smaller scale. If the Galilee structure is a cairn, it would be the most ambitious example from this region by a considerable margin. But the absence of any confirmed burial evidence, even after the limited investigation that has been conducted, means this remains a hypothesis rather than a conclusion. The ritual platform idea is harder to evaluate, partly because ritual is one of those categories that tends to absorb things we don't otherwise understand. Calling something a ritual site is sometimes a way of saying we don't know what it was for, and that's worth being honest about. But there is a genuine case to be made that large stone constructions in this region during the Bronze Age and earlier were associated with communal gathering, with ceremony, with the kinds of practices that reinforced group identity and social cohesion. Rujam el-Hiri has been interpreted in these terms. The stone circles and alignments of the Golan more broadly have been read as evidence of a landscape that was organised around shared symbolic or ceremonial meaning, not just practical agriculture or settlement. If the Galilee structure fits into that tradition, then it might represent a place where people came together, perhaps seasonally, perhaps for specific events, in a way that required a permanent, visible, substantial marker of that gathering. There is also the possibility, which is rarely discussed but worth raising, that the structure served multiple purposes across its history. A construction that took significant effort to build is not necessarily used for the same thing across centuries or millennia. A cairn might become a gathering place. A platform might be reused as a landmark. The lake itself was a resource, a boundary, a road, and the structure sitting in or near it might have meant different things to different generations of people who encountered it. This kind of layered meaning is common in the archaeology of long-lived sites. Stonehenge was modified and reused across roughly 1,500 years of its active history. There is no reason to assume that the Galilee structure, if it was built early enough, had a single fixed purpose from the moment of its construction to the moment it went beneath the water. What the structure implies most clearly, regardless of its specific purpose, is that the society that built it had something we might loosely call institutional capacity. Not institutions in the modern bureaucratic sense, but the social structures, the norms, the authorities, the shared understandings that allow large groups of people to work together on a project that benefits no single individual in an immediately obvious way. This kind of capacity is not a given. It has to develop. It has to be maintained. And its presence in a society leaves traces, not always in the written record, which does not exist for this period, but in the physical record of what that society chose to build and how it chose to build it. The Galilee structure is, in that sense, a trace. A very large, very heavy, very durable trace of a society that had figured out how to organise itself around a shared goal in a way that left a mark on the landscape, or in this case, the lakebed, that is still visible thousands of years later. That is not a small thing. In fact, it is one of the more remarkable aspects of the structure when you sit with it for a moment. We are talking about people who left almost no other record. No writing, almost certainly. No monumental architecture on the surrounding land that has been definitively linked to the same period and the same community. No named leaders, no documented beliefs, no preserved accounts of what they thought they were doing when they stacked those basalt stones into a cone 60 metres across. And yet the cone is there. It outlasted everything else. It outlasted the people who built it, the language they spoke, the beliefs they held, the settlements they lived in. It is sitting on the floor of a lake in northern Israel, roughly intact, waiting to be understood. There is something quietly moving about that, if you let yourself think about it. Not in a dramatic way, more in the way that old things sometimes make you feel the distance between now and then in a very physical sense. The structure is not a ruin in the usual way. Ruins imply something that once stood and then fell. This is something that was built, and then the world changed around it, and now it is underwater. It did not collapse. It was not destroyed. It was simply overtaken by time and water, and it kept its shape. That kind of persistence is, in a strange way, its own form of evidence. Evidence that whoever built it knew how to build something that would last, even if they could not have imagined the specific form that lasting would take. The broader implication for how we understand prehistoric society in the Levant is this. The region has a longer and more complex tradition of monumental construction than the textbook version of history tends to acknowledge. Göbekli Tepe pushed that recognition in one direction. Rujim el-Hiri pushed it in another. The Galilee structure, if it is as old as some researchers suspect, pushes it further still, into a period when the shores of this lake were home to communities that were, by any reasonable measure, doing something extraordinary. Not extraordinary in the sense of mysterious or inexplicable. Extraordinary in the sense that it required more coordination, more planning, more shared purpose than we typically imagine for people living in the 4th or 5th millennium BCE, let alone earlier. And if the structure turns out to be younger, if the dating eventually settles on the early Bronze Age rather than the Neolithic, it is still significant, because it would represent a scale of construction effort that has no clear parallel in the known record of that period in this specific region. Either way, the structure is telling us something about the people who lived here that we did not previously know. The details of what it is telling us are still unclear. But the general direction of the message seems to be the capacity for organised, large-scale, purposeful collective effort in this part of the world is older and more widespread than we have given it credit for. That is the kind of revision that archaeology occasionally forces on our understanding of the past. Not a dramatic overturning of everything we thought we knew, but a quiet, persistent expansion of the picture, an addition to the record that makes the record richer and more complicated and more interesting. The Galilee structure is one of those additions. It is sitting there in the dark water, patient and enormous, and it is waiting for someone to finally ask it the right questions in the right way. When that happens, when the tools and the funding and the institutional will finally come together and a real investigation begins, the answers it gives will almost certainly reshape what we think we know about the people who built it, and about the world they inhabited, and about what human beings were capable of long before anyone thought to write any of it down. Which brings us, in a way, to the lake itself, and to what it means that this structure has been sitting beneath it, in plain sight and yet completely hidden, for so long. So let us return to the lake. The Sea of Galilee on an ordinary morning looks the way it has probably always looked, more or less. The water is still and pale in the early light. Fishing boats move slowly along the western shore, following routes that fishermen have been following here for thousands of years. Pilgrims walk paths near the water's edge, reading familiar passages in their heads, looking out at the same surface that appears in stories they have known since childhood. Tourists photograph the hills. Children wade in the shallows. The lake does what lakes do. It reflects the sky. It ripples when the wind comes through. It sits quietly inside its ring of hills and goes about its business. And beneath all of that, roughly 9 to 16 metres below the surface in the southern basin, something enormous sits in the dark. It does not move. It has not moved, as far as anyone can tell, in a very long time. It is made of basalt, dense, dark, volcanic stone. The same stone that forms the hills around the lake, the same stone that the region has always been built from. Someone stacked it. Someone carried it, or rolled it, or dragged it, and placed it with enough care and intention that it still holds its cone shape after what may be thousands of years. And then, at some point, the water came up around it, and it disappeared from the world's attention, and the world kept moving above it without really noticing. That is, in some ways, the most remarkable thing about this structure. Not its size, though its size is genuinely extraordinary. Not its age, though its age is still uncertain enough to be unsettling. The most remarkable thing is the hiding. The fact that something this large, 230 metres across at the base, 12 metres tall, 60,000 tons of stacked stone, managed to sit beneath one of the most historically significant, most visited, most studied bodies of water in the entire world, and simply not be formally noticed until 2003. Think about what was happening above this lake in the centuries between its construction and its rediscovery. Fishing communities built their villages on these shores. Roman administrators taxed the catches. Byzantine monks built churches on the hillsides. Crusaders rode through the valley below. Ottoman farmers worked the land that slopes down toward the water. And through all of it, the structure sat, patient, unreachable, not quite visible from the surface, not quite invisible either, just below the threshold of formal attention in a part of the lake that people crossed but did not study. There were probably moments when the water dropped low enough that someone standing in a boat or wading in the shallows might have seen the top of the cone breaking the surface, or something like it. There is a reasonable chance that local fishermen knew about some kind of anomaly in the southern basin, a place where the bottom came up unexpectedly, where nets sometimes snagged. Whether anyone thought to document it, to ask what it was, to connect it to anything larger, that is a different question. The kind of knowledge that lives in a fishing community does not always make it into the written record. And the written record is mostly what survives. Yitzhak Paz and his colleagues were not looking for it when they found it. That is worth remembering. The sonar survey in 2003 was part of a broader mapping effort, the kind of methodical background work that precedes more targeted investigation. The anomalous return from the southern basin was not expected. And even after the follow-up dives confirmed that something was there, something large, something clearly not natural, it took another 10 years before the findings were formally published in the International Journal of Nautical Archaeology in 2013. Science moves carefully, sometimes frustratingly so, but carefully. The paper, when it came, was measured and precise. It described what the sonar had found, what the dives had confirmed, and what remained unknown. It did not overclaim. It presented a discovery and asked in the language of academic restraint what it might mean. The academic response was cautious curiosity, which is probably the right response to something this strange. Not disbelief. The physical evidence is too clear for disbelief, but a kind of careful, slow-moving interest that has not yet produced the full investigation the structure deserves. The University of Haifa has remained involved. Danny Nadell has continued working on it. Multibeam sonar has mapped the structure in more detail than the original survey could manage. Underwater photography has given researchers a better visual record. Sediment coring has been attempted around the base. But a full excavation, the kind that would involve systematic removal of material, careful stratigraphic recording, the recovery of datable organic samples from within the structure itself, has not happened. The reasons are a mix of practical and institutional, cost, logistics, the water authority's jurisdiction over the lake, the sensitivity of the ecosystem, the sheer difficulty of doing careful archaeological work in murky water at depth. None of these are trivial obstacles. All of them are real, but they mean that the structure is still, in the most honest sense, largely unstudied. What we know about it is still mostly what the sonar and the brief dives have told us. The cone shape, the basalt construction, the approximate dimensions, the absence of mortar, the deliberate arrangement of stones that rules out a natural origin, and the silence, the complete absence of the kind of evidence that would let us say with confidence, when it was built, who built it or what it was for. That silence is not comfortable exactly, but it is honest, and there is something worth sitting with in the honesty of it. We live in a time when the past feels increasingly accessible, when satellite imagery and ground-penetrating radar and ancient DNA analysis are revealing things that previous generations of researchers could not have imagined knowing. And yet here is a structure that has been sitting in a lake in a well-documented region for potentially thousands of years, and we still cannot tell you who built it or why. The tools exist to learn more. The will and the funding and the coordination have not yet fully arrived. But they may. Eventually they probably will. When that happens, the answers will matter in ways that extend beyond this one structure. Because the Galilee structure does not sit in isolation, even if it sometimes feels that way. It sits within a landscape that was inhabited continuously and in various forms for a very long time. The Jordan Valley and the shores of this lake were home to some of the earliest farming communities in the world. The Chalcolithic period in this region produced remarkable things: copper tools, elaborate burial practices, art that shows a sophisticated, symbolic life. The early Bronze Age brought larger settlements, more complex social organisation, the beginnings of what we might recognise as urban life in a loose sense. And woven through all of that, in the hills and valleys around the lake, are the dolmens and stone circles and megalithic structures that suggest a tradition of large-scale communal construction that is still not fully understood. Rujum El Hiri, about 16 kilometres from the lake's eastern shore, is part of that tradition. So are the hundreds of dolmens scattered across the Golan Heights, some of them enormous, some of them clustered in groups that suggest organised cemeteries or ritual landscapes. The Galilee structure fits into this world. It is not an anomaly in the sense of being completely without context. It is an anomaly in the sense of being the largest, the most submerged, and the least explained member of a family of structures that are themselves still being pieced together. If the structure is as old as the more ambitious estimates suggest, Neolithic, perhaps 10 or 12,000 years ago, then it belongs to a period when the shores of this lake were home to people who were, in the global sense, very early experimenters with settled life. People who were figuring out, generation by generation, what it meant to stay in one place, to grow food, to manage a landscape, to build things that were meant to outlast any individual life. A 60,000-ton stone cone would be a staggering achievement for such a community. It would imply a level of social organisation that we do not typically associate with that period in this region. It would, in a quiet way, rewrite part of the story. If it is younger, early Bronze Age, perhaps 4,000 or 5,000 years ago, it is still significant, still unexplained, still the largest known submerged prehistoric structure in the region. The story changes in its details, but not in its essential strangeness. And the essential strangeness is this: someone built something enormous here, and then it disappeared, and then it was found, and we still do not know what it was. There is a kind of humility that comes from sitting with that. Not a defeated humility, not the sense that we can never know, but a quieter recognition that the past is larger than our current understanding of it, and that the earth has been holding things we have not yet asked about: the sea floor, the lakebed, the sediment layers beneath fields that have been farmed for centuries. There are almost certainly other structures, other objects, other traces of human effort that have not yet been found, not because they are hidden in any deliberate sense, but because no one has yet looked in exactly the right place with exactly the right tools at exactly the right time. The Galilee structure was found because a sonar survey happened to pass over it. It had been there all along. That thought, that things are there all along waiting for the moment of recognition, is one of the quieter pleasures of archaeology, and of the kind of deep history that archaeology tries to reconstruct. The world is not a closed book. It is more like a book that keeps revealing pages that no one knew were there. Some of those pages are dramatic, some are subtle, some are, like this structure, both at once. Enormous in their physical presence, elusive in their meaning. The fishermen on the lake this morning do not think about what is beneath them. Why would they? They are thinking about the weather and the catch and the fuel and the route back to shore. The pilgrims walking near the water are thinking about something else entirely, about the stories that brought them here, about the weight of the place, about what it means to stand where they are standing. The tourists are taking photographs. The children are still wading, and 60,000 tons of stacked basalt sits in the dark water of the southern basin, holding whatever it knows. It has been holding it for a long time. It can hold it a little longer, but not forever, hopefully. Because the questions it raises are worth asking seriously, and the tools to ask them exist, and the people who care about the answer are out there, in universities and research institutes and dive boats and government agencies, slowly, carefully, moving toward the moment when the investigation that this structure deserves will finally begin in earnest. When that happens, the lake will give up something it has been keeping for a very long time, and whatever it gives up will almost certainly be worth the wait. Until then, the structure remains what it has always been since the water came up around it, present and invisible, enormous and quiet. A fact about the human past that we have not yet fully absorbed. There is something almost comforting in that, if you look at it from a certain angle. The world still has edges we have not reached. The past still has rooms we have not entered. And sometimes, in a lake that has been fished and sailed and prayed over for thousands of years, there is something sitting on the bottom that nobody knew to look for until someone happened to look. Thank you for spending this time here. Genuinely. If you made it this far through all of it, through the basalt and the sonar and the Bronze Age and the deep water, then you are exactly the kind of person this channel exists for. If you found something in this worth keeping, please do consider leaving a like, and if you are not already subscribed, the button is right there. It helps more than you might think, and it means these kinds of stories keep getting told. Take care of yourself tonight, wherever you are. Sleep well, if that is where this is taking you, and we will be here when you come back.